The cookies in a jar contain a total of 1,000 chocolate chips. All but one of these cookies contain the same number of chips. It contains one more chip than others. The number of cookies in the jar is between 1 dozen and 3 dozen. What is the sum of the number of cookies in the jar and the number of chips in the cookie with the extra chocolate chip? All right, so let's introduce some variables and explain this question first before we tackle it. First, let x be the number of cookies in this jar. And then we know that x is between 36 and 12. They've given you that in the question. The number of cookies in the jar is between 1 dozen and 3 dozen. And then we know that there is a relationship. We have a whole bunch of cookies, and each of them has chocolate chips, right? But one of them is different. So we have one lone cookie, and then we have all the others, which will be x minus 1. These are all the other cookies. Now, all of these cookies, the x minus 1, have the same number of chips. So I'll call the number of chips n. Number of chips. But they've told you that this one lone cookie is special because it contains one more chip than the others. So it has n plus 1 chips. All right? I'll write that in there, chips. Chocolate chips. And there we go. So what do they want us to find in the question so that we don't get confused? What is the sum of the number of cookies, so x, and the number of chips in the cookie with the extra chocolate chip? Well, the number of chips in the cookie with the extra chocolate chip is n plus 1. So this is what they want us to find. All right, so let's go and proceed with the question. So we know that the number of cookies we have set to be equal to x. And now we have to figure out the total number of chips, chocolate chips. Well, with this lone cookie, we have n plus 1 chips. And then with all of these cookies, x minus 1 of them, each of them has n chips. So that is the mathematical formula to figure out the total number of chips. So let's figure this out. N plus 1 plus xn minus n. And they've told you the total number of chips. They've given you a value. If you remember, right there, total of 1,000 chocolate chips. So this is 1,000. So now let's solve for this equation. Let's see if we can isolate one variable. It looks like the n's cancel, so this just leaves us like this. Put the 1 on the other side, get 999 is equal to xn, and therefore x is equal to 999 over x. All right, and that's about as far as we can go. Oops, sorry. Don't make that mistake. Like that. Okay, so that's about as far as we can go. There's nothing at this point that we can do. But we can make a table and see what values we get. Because remember, x and n are both integers. X represents the total number of cookies, and n represents the number of chips, chocolate chips. And we also know that x is between 12 and 36. So x can be 13, 14, all the way down, to 35. And if you keep plugging in numbers for x, we have to get an integer value for n. And that's the only way this is going to work. So if you keep doing this, you'll get values that are not integers. And the only time you'll get an integer is with the number 27. When x is 27, you'll get an integer value for n, and that value is 37. And this is the only solution. So therefore, x is equal to 27, and n is equal to 37. And now let's see, they want us to find x plus n plus 1. Okay, no problem. X plus n plus 1 is 27 plus 37 plus 1, which is 65. And therefore the answer is, for number 25, A. Tony and Maria are training for a race by running all the way up and down a 700 meters long ski slope. They each run up the slope at different constant speeds. Coming down the slope, each runs at double his or her uphill speed. Maria reaches the top first and immediately starts running back down, meeting Tony 70 meters from the top. When Maria reaches the bottom, how far behind is Tony? So let's draw a diagram and explain this question. So you've got the ski slope all the way to the top and all the way to the bottom, like that. And that's going to be a right triangle, but I don't know if that's needed. And first, let's draw the path taken by Maria. We'll put her in orange. She goes up, all the way up like that. She gets to the top, and then she immediately starts coming back down. Okay? And when she is right here, so at this point right here, she catches up with Tony, and they've told you that that is 70 meters from the top, right there. They tell you that in the question. So Tony will have his path in green. He is going up the hill like that. And when he gets to that point, him and Maria meet for the first time. Okay? And then the second scenario is similar as you continue this race, I guess, what they call it, where Maria, she went all the way up, and then now she's coming all the way back down, and she reaches the bottom. But at this point, Tony is still running, right? He went all the way up, and he's coming back down, and he's going to be at a certain point when Maria reaches the bottom. So they are asking us, when Maria does reach the bottom, where is Tony? So if Tony is here, what is the distance from there to there? All right? So I hope that makes sense. If so, let's proceed with the mathematics of this. Well, there's a very important formula that speed is equal to, too many e's there, speed is equal to distance over time, right? So for example, they always say kilometers per hour or meters per second. Now this can be changed in any way you want. You can make it time is equal to distance over speed, and so on. So we will definitely need to use this formula. Okay? Now, the first thing, of course, is we have Maria and we have Tony. This scenario right here, let's concentrate on that. So scenario number 1. When Maria is going up the hill, she has to travel 700 meters because that is the length of the ski slope. And her speed, so this is the distance, her speed, we don't know. So we'll just call it x, no problem. X meters per second. Okay? Tony, when he goes up, he also is going up the same distance, 700 meters. But he meets Maria at this point right there, which is 70 meters from the top. So he actually doesn't travel a full 700 meters. He travels 700 minus 70, 630 meters. Correct? And we'll make his speed y meters per second. Okay? Now, is that Maria's full journey? No, she went up 700 meters, but she went back down 70. So she has a down segment of 70 meters. And what's her speed when she goes down? Read the question. Coming down the slope, each runs at double his or her uphill speed. So if she went uphill at x meters per second, she's going down at 2x meters per second. All right, so far so good. I hope you're following. I hope that makes sense. Okay, so let's move up here. Now they meet at the same time. Their times are the same at this point right there. All right, so that means we have to figure out time. We have to use this equation here. So for Maria, the time would be distance over speed, so 700 over x going uphill, and distance over speed going downhill, which is 70 over 2x. Right? Time for Tony is the distance divided by the speed, which is y. And these two times are equal because that's how they meet. They meet at the same time. So we can set them equal to each other. So let's set them equal to each other. So we got 700 over x plus 70 over 2x is equal to 630 over y. All right, this looks like a common denominator is going to be 2x. So multiply top and bottom by 2. So this becomes 1400 plus 70 all over 2x. Or if you want something a little bit more simpler, you can probably just divide through this guy here. So 700 over x plus 35 over x. There you go. It makes it easier. 630 over y. And this becomes 735 over x is 630 over y. And therefore 735y is equal to 630x. And let's see, this probably has, if you divide through by 5, 147y and 126x, divide through by 49, or divide through by 3, let's say. This gives you 49 and 42. Oh, divide through by 7. There you go. 7y, 6x. There you go. 7y is equal to 6x. So we can deduce from this that x, if we let it equal 7 meters per second, and y, therefore, will be 6 meters per second. We can work with these. As long as we hold this relationship, we should be okay. By inspection, I'm getting these two speeds. So now let's go back, and now let's look at this scenario right here. Scenario number 2. Okay, so I'm going to write my speeds here. X was 7 and y was 6. All right. Now this scenario, number 2, what's happening is Maria goes all the way up and she's come all the way down, right? That's Maria represented by the orange lines. Tony has gone all the way up and come back down until this point right here, and he's represented by the green line. So in a very similar way, we have to now figure out this distance right there. From the time that Maria reaches the bottom, where is Tony? So when Maria went up the hill, she has a speed of 7 meters per second, and her distance is 700 meters. When she went down the hill, all the way down to the bottom, 700, same distance, but her speed is double, remember. When she goes down the hill, it's double. So this is distance, this is speed. So we have to figure out her time, total time, going all the way up, going all the way down. Well, time, if you remember, was distance over speed. So going up, it's 700 over 7 plus 700 over 14 for when she goes back down. So this looks like 100 plus 50, so 150 seconds. So she takes 150 seconds to go all the way up and all the way down. All right, keep that in mind. Now, we turn our attention to Tony. How much time does it take him to go all the way up the hill? Well, he goes up the hill. The distance is, of course, 700. And the speed, his speed is 6 meters per second. So when he goes up the hill, his time is 700 over 6, which is equal to 116.66 seconds. All right? So from the bottom to the top, it takes him 116. Now, we have to understand that Maria takes 150 seconds to go up and down. He's already traveled for 116 seconds. So he has how much more time to travel? He has to travel an additional 150 minus 116.66 seconds, which is 33.33. Correct? Because Maria traveled up the hill in 150 seconds, and then when she came all the way back down, Tony had only reached this point right here. But it took him 116 seconds to get all the way to the top, so the remaining amount of time is how much time it took him to get to that point. So we have to figure out his distance after 33.33 seconds going downhill. So now we've got time is equal to 33.33, and distance is what we're trying to figure out, and speed. What's our speed going downhill? It's 2 times 6, remember? So it's 12 meters per second. So what is our formula for distance, speed, and time? Remember, speed is equal to distance over time. And therefore, if we want to figure out distance, distance would be equal to speed times time, like that. So distance in this case, speed is 12 meters per second, time is 33 seconds, 33.33. So this equals 400. So that means from here to here is 400 for him, for Tony. From here to here, all right, is 400. But we want to find this distance. Well, the total distance of the hill is 700, so that distance is 700 minus 400, which is 300. So when Maria finishes this race, Tony is at this point, and that point is 300 meters from the bottom. And therefore, the answer for number 25 is D. Emily has created a jumping game using a straight row of floor tiles that she has numbered 1, 2, 3, 4, ... Starting on tile 2, she jumps along the row, landing on every second tile, and stops on the second last tile in the row. Starting from this tile, she turns and jumps back toward the start, this time landing on every third tile. She stops on tile 1. Finally, she turns again and jumps along the row, landing on every fifth tile. This time she stops on the second last tile the number of tiles in the row could be. So we definitely need to explain this. So we've got a whole bunch of tiles, right? And I'll just draw very quickly these tiles. They're all basically going to be numbered something. So we've got 1 as the first one, 2, 3, 4, and then like that, so on, 5, 6. So she starts right here. She starts on tile 2. She jumps along the row, landing on every second tile. So she's going to land on 2, 4, 6, 8, every second tile, 10, 12, 14, 16, like that, onward, 18. Well, you get the point. Dot, dot, dot. And then she eventually stops on the second last tile. So I'm going to make this my second last tile. Okay? So if the number of tiles, I'll call it n. This is n minus 1, the second last tile. So then she starts to go in the other direction. Starting from this tile, n minus 1, she turns and jumps back toward the start, but this time every third tile. So she's going back. So for example, if she's here initially, she's going to go 1, 2, 3, and then 1, 2, 3, like that. All right? And then eventually she gets all the way back to 1. And then now again, she turns again and jumps, but this time landing on every fifth tile. So she's going to basically jump to 6, and then 11, and then 16, and then 21, and so on. And then she finally stops at, again, the second last tile. So I hope you understand how she's jumping. They want you to figure out the number of tiles, or at least one possible number. So they want you to figure out the value of n. Okay. So first, we've got 3 scenarios, right? The first scenario is when she's going from tile 2 and jumping every second tile. So she eventually lands at n minus 1 right here. So that means that n minus 1 must be a multiple of 2, right? Because think about it. She's going 2, 4, 6, 8, 10, 12, and so on. And eventually she lands on n minus 1. So n minus 1 has to be a multiple of 2. That's the only way that she could ever land on it, because all the others are multiples of 2. 2, 4, 6, 8, 12, and so on. So that's our first condition. Then once she is at n minus 1, she turns around, correct? And then she goes back. But this time she's landing on every third tile. And eventually she comes all the way back to 1. So we have to now figure out a condition for that. How do we do that? Well, she started at n minus 1, correct? And she goes all the way back to 1. So if you subtract that 1, that means that the remaining had to be divisible by 3, correct? For example, if you remembered when she was jumping back every 3, she landed on the 16, right? Or at least that's the way I drew it, because I wanted to draw this accurately. Now she lands at 1 by going back every 3, right? So 1, 2, 3, 13, 1, 2, 3, 10, 1, 2, 3, 7, 1, 2, 3, 4, and then 1, 2, 3, 1. So it is accurate that 16 is one of the squares or floor tiles that she lands on. So let's just say our n minus 1 was 16. It's not, but let's just say it was. That means that if you subtracted 1, where she eventually lands, then the only way that could have happened is if all the other ones were divisible by 3. So if you plug that in, you'll watch n minus 1 is 16, minus where she lands, that's 15, and 15 is indeed divisible by 3. It's 5, so she had to make 5 jumps, 1, 2, 3, 4, 5. So I hope that makes sense as to why this is our next condition. So if you simplify that, it becomes n minus 2 is divisible by 3. Now let's get to our final scenario, which is she starts at 1 and she starts jumping in the other direction, but this time she's landing on every fifth one. So she lands on 6 and then 11 and then 16 and so on, right? So that leads to another relationship that very similar. She's going to eventually land on the second last tile, n minus 1. So she ends up right back there again. So that means that n minus 1, which is where she lands, minus the first tile, has to be divisible by 5. That's the only way this could work, because she's making a jump every fifth tile. So that leads us to our third condition, which is n minus 2 is divisible by 5. So we have to find a number that meets all of these conditions. All right? So let's look at our choices. We got 39. Let's see. Does 39 match? N minus 1 over 2 would become 38 over 2, and that is indeed divisible, right? Because it's 19. All right, that's good. How about n minus 2 divided by 3? N minus 2 would become 37. Is 37 divisible by 3? And the answer is no, it's not. It would be 12 point something. Okay, so 39 is gone. How about 40? Is 40 minus 1 divisible by 2? That becomes 39 over 2, and no. All right, that one's gone. How about 47? 47 would be n minus 1 divided by 2 would be 46 divided by 2, which is 23, so that one is divisible. How about our next condition, n minus 2 divided by 3, so that would be 45 divided by 3, which is 15, so that's fine. And our final condition, n minus 2 over 5 will give you 45 divided by 5, which is 9. So that works also. So 47 satisfies our three conditions, and therefore that is the answer to number 25, C. In the diagram, a positive integer is to be placed in each of the 9 boxes so that the products of the numbers in each row, column, and diagonal are equal. Some of the entries are already filled in. The number of possible values for n is. So here's that diagram blown up. And first we need to figure out what is that product. They're saying that the product of all the numbers in each row, column, diagonal are equal. But what is that famous product here that they refer to? Well, there's only one diagonal that has all three numbers. So let's use that to figure out our product. And that is, of course, just 6 times 12 times 24. And that number is 1728. Okay? So if you take the numbers in any row, column, or diagonal and multiply them, they have to equal 1728. All right, no problem. Let's label this A, any order, B, C, D, E. The order doesn't matter. I mean, you can label them any letters you want just as long as you understand the question. So now let's systematically work one at a time. First, I'll concentrate on these three. N times A times 6. That has to equal 1728, right? Because every row, column, diagonal, when you multiply the numbers in them, they have to equal the same. And our product is 1728. So from that I get n times A is equal to 1728 divided by 6, which is 288. And therefore A will be 288 over n. So this is 288 divided by n. My goal is to get everything in terms of n, and then I can compare them. All right, so we took care of one. And in a very similar way, let's look at that. N times C times 24 is equal to 1728. And therefore n times C is equal to 1728 divided by 24, which is 72. And therefore C is equal to 72 over n. So 72 over n, like that. All right, where do you want to go next? How about the b? n, b, and 12? Right here, n, b, and 12, this diagonal. So that means n times 12 times b is 1728. And therefore n times b is 1728 divided by 12, which is 144. And therefore b is equal to 144 over n. 144 over n. And I think we got, what, 2 more? All right, we can do this. 1728 is going to be equal to 24 times d times 144 over n. I'm basically doing this guy right here, this column. And if you do the math here, you'll get that d is equal to n over 2. So that's n over 2. And one more, e. So 6 times e times 144 over n is equal to 1728. And if you do the math, you'll get e is equal to 2n. So there you go. We got all the boxes filled. So I am going to list those. Let's see, we got n over 2. Let's list them from smallest to largest. N over 2, 2n, or 72 over n. Or maybe this isn't being listed in any kind of order, but that's okay. At this point, we just want to figure out the answer. 288 over n. These are our values, right? These are what we need to figure out. Okay, so here we go. Now, what is the criteria of the question? The criteria is all of these numbers have to be integers. And that's the only way we are allowed to fill that magic square or magic table. So we have to find values of n that make all of these integers. Okay, well, I think that shouldn't be too hard. If I choose any integer for n over 2 will be an integer only if n is even. 2n will be an integer regardless for any n. If n is an integer, 2n will be an integer. So we don't have to worry about that guy. But these guys here, it's a little bit trickier. The only way that this can be an integer is if n divides into 72. So 72 divided by n has to be an integer. And the only way that can happen is n is a factor of 72. And very similarly, these guys will become integers in the same way if n is a factor of 72. Because if you notice, this is just 72 times 2, and this is just 144 times 2. So I need to concentrate on the factors of 72. All right? So what are the factors of 72? Let's see, we got 1. Before I make a list, a lot of times it just helps to break it down to its prime factor. So it's be 2 times 2 times 2 times 3 times 3, I believe. So that's what, 8 times 9? Yeah, 72. Perfect. Okay, now let's list all the factors of 72. Don't forget 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. How many did I get there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So 12. 12 is one of the answers. But before you choose that, let's not get too hasty here. Let's go back and see if all the criteria is filled. If n is one of these guys, then this will be an integer, this will be an integer, and this will be an integer. And it's already an integer. 2n will be an integer. So everything is going well. But we got one that is not so easy. The only way that can be an integer if n is even. So of these 12, we only can use the even numbers. So what are those? I'll circle them. These ones. And how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So a little bit tricky there. A lot of people would choose 12, but you can't choose 1, 3, and 9 because if you did, this would not become an integer. So 9 is the answer, and therefore, number 25, the answer is C. A large block which has dimensions n by 11 by 10 is made up of a number of unit cubes and one 2 by 1 by 1 block. There are exactly 2,362 positions in which the 2 by 1 block can be placed. What is the value of n? So first let's draw a diagram and let's label this. So I'll label this side 11, and this side 10, and this side n. Now these gaps is because we don't know, right? How big is n? So that's why I wrote ... and I left little gaps there to kind of illustrate that. Okay, so let's work with this. Now there's a few scenarios, right? The first scenario, of course, is when you're placing this block up here. So I'll just start here. And these are unit cubes, so we can just place the block like this. Okay? So in the first scenario, we have to figure out, how do I place this block here, this guy right here? This is at the heart of the question. Okay, I can place it like this. 1 position there, right? 2 position, and so on. 3rd position, 4th position. Well, you get the idea. And if I do, how many such positions can I put it in? Remember, it's a block, it's not a line, so it's got to cover all the way till there. All right, so it's a little bit of a conceptual challenge, I think. If this is my block, it's going to be kind of like that, right? So very quickly you can figure out that if you make a table, and my first scenario is the horizontal placing, that I'm going to be able to do that all down the rows, 1, 2, all the way down to the nth row. All right, and in the first row I can put it in 10 positions. It can go here, that's the first position, second position, and if you count all the way down, you'll get to 10 positions. All right, so 10 ways of putting that horizontal block. Putting that block horizontally, better way of saying that. So in row 1, there's 10 ways, row 2, there's 10 ways, all the way down to the nth row, 10 ways. So the total is 10n. All right, now keep in mind, that only takes care of one slab of this big block, I guess, this big shape. We have to do this for that slab, for that slab, for that slab, right? And how many slabs would there be? There'll be 10 of them. Right there, it's 10, right? And each slab has a length of 1 because they're made up of unit cubes. So 10n only takes care of one slab, so all of the 10 slabs, it would be 10 times 10n. Okay? So I did that slowly to help you understand. Unfortunately, we're not done. We're not even close to being done. But I'm doing this so that you can understand this, doing it in a careful way. Now let's look at the vertical possibilities. And vertical meaning if we're going down like that way. Okay? Now we've got n of these, so I have no clue how far this goes down. So I'll just start putting in unit cubes like that. Now if I put the 2 by 1 by 1 block in a vertical position, it could probably go here. That's definitely one possibility. Correct? So basically like that. That's 1, 2, and 3, and so on, right? 4, 5, and so on. But the better question is, how many? Well, in the first column, column 1, n minus 1. N minus 1 times you can place that block. And that should make sense, right? Because when we did it for 11, it was 10. Column 2, exact same, n minus 1. How many columns do we have? We've got 11 columns in this scenario. So all the way down to column 11. Now let's add this up. 11, and each of them has n minus 1, so 11 times n minus 1. For that slab, only for that slab. Okay? But how many slabs are there? Well, there's 10, correct? So the total has got to be 10 times 11 times n minus 1. Okay? And I'll just simplify these. We can do that later, but just for the sake, 100n, and this is 110n minus 110. Okay? Now we have done two scenarios, and I'll label them. This is scenario 1, and this was scenario 2. How many more scenarios do we have? We have 4 additional scenarios. Okay? So it's a little bit of a challenge, but it's actually not so bad. The next one, I'm going to concentrate on this part of the diagram right here. Right here. Okay? Let's draw it in red just to show you that I'm doing it a little bit different here. This guy right here. Just that slab right there. Okay? So here we go. Just drawing a couple more lines just to, I think that should be enough. Don't want to make it too complicated. Okay, in that one, let's start with the horizontal direction first. In the horizontal direction, in a very similar way to what we did previously, we got row 1, row 2, all the way down to the nth row. And in each, how many ways can I place the block? Well, let's see. I could place it like here, one way, right? I'm going horizontally, 2 ways, right? And so on down. And because the length is 10, 9 ways of doing that for each row. Okay? So that means that the total for this particular scenario is 9 times n. But we have to do that for all the slabs. All of these guys. And if you do that, you have to multiply by which number? 11. Correct? So this total becomes 11 times 9 times n. And that is, of course, just 99n. So this one I'll call scenario 3. So far, so good? No problems? You understand it? Let's go with vertical. This guy right here, that slab, but now going up and down. In a very similar way to what I did over there, we now have to look at the columns. So column 1, column 2, dot, 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 until how many columns? 10 this time, right? Because the dimension is 10. And each column, how many times can I put that cube or that block? Well, I can put it like 1, 2, and so on, 3, all the way down to the bottom, and that would be how many? n minus 1. So n minus 1 here, n minus 1 here, and so on. So the total is 10 times n minus 1 this time. But that only takes care of one slab, so I've got to figure it out for all the slabs, and there's 11 of those. So this is 11 times 10 times n minus 1. And I'll call this scenario 4. Now here is where the question, the heart of the question in terms of getting the right answer, I guess. This scenario that I just did, 4, I've already done previously. So I don't need to count that because I've already counted it. Which one of the previous 3 is it? You can figure that out conceptually, Or the beauty of this question is you can figure it out mathematically. It'll have the exact same value. So which one has the exact same value? Even if it's in terms of n, which one has the exact same value as number 4? Is it scenario 1, scenario 2, or scenario 3? It is scenario 2. Right here. This is the same as 4. So same as 4. So that one does not need to be counted. So I'll just put already counted in the text right there. All right, we've got only 2 more scenarios and we can solve this question. The next one is this guy right here, up at the top, right here. So I'm going to put those in green to let you know that it's a slightly different part of the diagram. Okay, so far you're an expert now, I think. Horizontal and vertical. So in the vertical, well, first of all, I have to tell you which one is horizontal. I'm going to call these guys horizontal. If you're going from there to there, and it doesn't really look horizontal, but if you flipped it, I guess it would be. Horizontally, first of all, how many rows? Row 1, 2, all the way down to 11. Okay? So there's 11 rows this time. Dot, 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 all the way till 11. And in each row, how many times can I put the block? Well, 1, 2, and so on, right? But the dimension there is 10, so that's going to be 9 times that I can put it. 9, 9, all the way down till 9. So the total here is actually 9 times 11. But as always, we have to consider the fact that that's only one slab, and there's a bunch of other slabs going down, right? And how many slabs do we have in this orientation? N. So this total is n times 9 times 11. All right? And I'll call that scenario 5, like this. Now scenario 5, guess what? It's already been counted. Now you tell me which one of those first 4 is the same as scenario 5. I'll give you a hint. It has the same numerical value. It's this one right here, scenario 3. Even if you're having a difficult time conceptually, mathematically it's right there in front of you. That was basically 99n. It's the same as 3. So same as 3, already counted. Okay? I'll put that in there, already counted. And therefore we only have one final scenario left, and that's the vertical one on this guy. So vertical, we're going to be looking at columns, and I have to be careful here. I have to tell you, this is vertical in this guy. All right? So, okay, no problem. Vertical in the columns. Column 1, 2, how many columns do we have in this case? We've got 10 columns this time. Okay, because this dimension is 10. And in each, you can put the block here, or you can put the block here, correct? And all the way down. So how many is that? It'll be 11 minus 1. So that's 10. So 10, 10, and 10, like that. So the total will be 10 columns, and each you put 10, 10 times 10. And then, as always, you have to keep in mind that that's just for one slab. For all these slabs, since there's n of them, this dimension is n, this total will be n times 10 times 10. And this is the 6th scenario. Now what we have to do is add up the scenarios, except for the ones that we counted twice. So I'm going to include 1, I'm going to include 2, I'm going to include 3. 4 is already counted, so I can't include that. 5 is already counted, so don't need to include that. And 6 is not already counted, or is it? right? It's a good question. Don't get it all, okay, I know the answer. Again, mathematically and conceptually, you should be able to see that 6 is the exact same as 1. So same as 1, and therefore already counted. Now, the reason I did it so thoroughly is because I want you to understand it. I don't want to say just, oh yeah, well, this scenario you don't need to do because it's already counted, and then move on. Because you might think, well, I don't understand that. Why is it already counted? So I have to show you, and not just in terms of a visual way, but also in a mathematical way. So 6, you also don't need to count. So the only ones you need to count are 1, which is 100n, 2, which is 110n minus 110, and 3, which is 99n. And these all equal what? They tell you, right? 2, 3, 6, 2. That is the number of positions. So 2, 3, 6, 2. All right, let's do this. So we got 100, 110, and 99. So that looks like 309n. And then 2362 plus 110. So this becomes 2472 is 309n. And n, 2472 divided by 309. And if this is not an integer, I give up. But fortunately it is. It is 8. So actually it's a little bit smaller than I had thought it was. No problem. Number 25 is 8, and therefore the answer is B. A purse contains a collection of quarters, dimes, nickels, and pennies. The average value of the coins in the purse is 17 cents. If a penny is removed from the purse, the average value of the coins becomes 18 cents. How many nickels are in the purse? So we got pennies, nickels, dimes, and quarters. So the number of pennies times 1, which is the value of a penny, plus the number of nickels times 5, which is the value of a nickel, plus the number of dimes times 10, plus the number of quarters times 25, is the total sum of the amount of money. And of course you have to divide by the number of coins, which in this case would be the number of pennies plus the number of nickels plus the number of dimes plus the number of quarters. And they say that when you do that, you get 17 as your average. All right, so that's your first equation. I'll multiply this out, and I'll get P plus 5N plus 10D plus 25Q is equal to 17P plus 17N plus 17D plus 17Q. And putting everything on one side, you'll get 16P plus 12N plus 7D minus 8Q. Okay? And that's equal to 0. And I think that's about as far as we can go there. Now let's take into consideration the next piece of information in the question. If a penny is removed from the purse, the average value of the coins now becomes 18 cents. So exactly what we did here, but instead of P, it's P minus 1, right? Because 1 penny has been removed. Everything else is the same. 5N, 10D, 25Q. And then the denominator, this time, we have 1 less coin. So it's P minus 1 plus N plus D plus Q. And that, they tell you, is equal to 18 cents. Okay? So this becomes, let's see here, P minus 1 plus 5N plus 10D plus 25Q. And that is equal to 18P minus 18 plus 18N plus 18D plus 18Q. All right, let's put everything on one side. 17P plus 13N plus 8D minus 7Q. And then, let's see here, minus 18 plus 1, so minus 17 equals 0. All right, I got two equations. I'll call this equation 1. I'll call this equation 2. Now I've got to combine these because both of these conditions have to hold true. How do I combine them? I'll just do 2 minus 1. I think that will allow me to at least get rid of one variable. Or maybe not. Well, we'll see. Or maybe it doesn't help me at all. Who knows? Let's say 2 minus 1. I've got to combine them somehow, though, because otherwise they wouldn't give both pieces of information in the question. 2 minus 1, let's see here, P plus N plus D plus Q minus 17. All right, that looks good. I like the way that looks. So that means that P plus N plus D plus Q is 17. So that means there's 17 coins. Okay. That works out pretty decent, I think. Now we have to figure out how many nickels. All right. All right, so I think at this point, because there's so many variables, this has got to be done entirely by inspection. Because if you have 4 variables, you would need 4 equations to figure out each variable. All right, so let's make a little table here. Hopefully we don't have to rack our brains too long to figure out the answer. Okay. All right, so we got 17 coins. And we know that the average of these 17 coins is going to be 17. So that basically means that if I take the sum of the value of the coins, which would be P plus 5N plus 10D plus 25Q, and divide by the number P plus N plus D plus Q, that average is 17. All right? That means P plus 5N plus 10D plus 25Q is going to be 17 if you cross multiply times this, but that we know is 17. So it'll be 17 times 17 like that, which is 289. So I've got to figure out, how do I get a sum of 289 if I use pennies and quarters and dimes and all that stuff? Okay, well, the first thing I notice is that everything is a multiple of 5, right, except the pennies. Quarters, dimes, and nickels are a multiple of 5. But I've got 289. And that's not a multiple of 5, so I'm going to subtract 4 pennies from that. So I'm going to let P equal 4. And if I do that, that means I've got 285 cents remaining that I've got to make with the nickels, dimes, and quarters. Now, it shouldn't be that hard to figure out how to do that. How about if I use a whole bunch of quarters? If I use, say, I don't know, if I get close to that, 275 would be, what, 4, 4, and 3, so 11 quarters. 11 quarters would bring me to 275, so that means I've got 10 cents left. I can make 10 cents with 2 nickels. All right, that is definitely true, but I've got to figure out this in a way so that my coins equal 17, the number of coins. Let's see, 4 pennies, 2 nickels, 11 quarters. That is 6 plus 11. That is 17 coins. Great. I think I've done it without too much pain and suffering. So there you go. We've got 4 pennies, 2 nickels, 0 dimes. Yeah, 0. I'll put a 0 in there for dimes, and 11 quarters. And what they wanted us to figure out in this question was the number of nickels, and that's 2. So therefore, number 25, the answer is A. In the diagram, the numbers from 1 to 25 are to be arranged in the 5 by 5 grid so that each number except 1 and 2 is the sum of its 2 neighbors. Numbers in the grid are neighbors if the squares touch along a side or at a corner. For example, 1 has 8 neighbors. Some of the numbers have already been filled in, which is the number that must replace the question mark when the grid is completed. So first, let's just explain the neighboring system. Look at 1, right? all the numbers that surround it are technically its neighbors because they share a side or they share a corner. So for example, number 1 shares a side with 5, right? So that's a neighbor. But number 1 shares a corner with 6, so that's also a neighbor. So that is how they're getting these numbers. So for example, let's talk about this. 1 and 2 are the ones that are not included in this system. They tell you that, except 1 or 2, but everything else is included. So how did we get a 3? Well, it's 1 plus 2, right? These two guys. How do we get a 4? It's 1 plus 3. We added 2 of its neighbors. How do we get a 9? Well, it's 1 plus 8. 2 of its neighbors. See what I mean? As long as a number surrounds a number, it's called a neighbor. So, for example, 25, what are the neighbors of 25? Any number that surrounds it. So this number, and this number. See what I mean? So I just want to explain that. Hope you understand that neighboring system. Okay, now our task is to complete this diagram. So let's go for it. So I've blown it up a little bit, and what I'm going to do on the side is write down all the numbers from 1 to 25, and we're going to start crossing out numbers that have already been filled in. All right, well, a lot of these have already been filled in, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All these guys have already been put in. We've also, the question has put in already 20, 21, 22, 23, 24, 25. So we only have, 10 numbers to actually fill in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Let's proceed with this. So first, let's do the ones that are the easiest. And I'm going to start right here. 21 can only be made with a sum of its neighbors. And these are the neighbors. This guy, and this guy. All right? Well, we only have 3 choices. 20 plus 1 could give you 21, but 1 is not a neighbor. And I can't put 1 here. Why? Because 1's already been placed. So 20 is out. To get 21, that's not going to be useful for me. But 4, obviously. So 4 plus something has to equal 21, and therefore that x must be 17. So therefore this 17 I will circle. 17 guaranteed goes there. All right. Now let's go anywhere else. Is there some guarantee here? And I think in this corner right here. 25 has to be made somehow with its neighbors, and it only has 3 neighbors. This guy, and this guy. Well, the first 2 numbers, 9 and 24, when you add those up, it's 33. So obviously that's not going to work. 24 plus 1 will give you 25, but the 1's already here. So that means to get 25, I've got to basically use 9. 9 plus this number has to give me 25. And therefore that number has to be 16. It's the only way. So there you go. All right. So far so good. I hope, you're following. No problem, right? Now at this part of the question, we have to start, there's no guarantees anymore. Now we have to start fiddling around and using trial and error. And it's not too bad. Just stay confident and don't get flustered. If you put in a number, it doesn't work, no problem. Just try again. All right? So where am I going to go here? I'm going to try to concentrate on this region here. I know you think, well, the question mark's over here. Why don't you concentrate on that region? Well, because if I put something in there and it works, right, this area may not work. You see what I mean? I've got to fill in the entire grid. So if I can fill in this part and it works, then I know I'm in a great position to concentrate on the final part. Okay, so first let's look at all the numbers that are left, right? The ones that are not circled. That is going to give us a clue as to what we should put in the empty boxes. All right, so let's see here. This is what I want to concentrate on. Well, somehow I got a sum of 20, right? So how did I get a sum of 20? One of these neighbors has to add up to another one of its neighbors to get 20. Well, there's lots of possibilities. 21 is obviously greater than 20, so that's not going to help me. But 17 plus 3, but 3 is already here. Okay, no good. 4 plus 16, but 16 is already here, so that's no good. So 5 plus 15. It's the only way. So there you go. 5 plus 15 is the only way to give 20. So interestingly, that was another one that's kind of guaranteed. I thought I had run out of guaranteed ones, but I guess there was one more. But perhaps now is when the guessing game really begins. Okay, no problem. I think we should be able to figure out this corner here. All right, like I said, it's trial and error. There's nothing wrong with making a mistake. I'm going to try to put something in there. What number should I put? I don't know. I have no idea. Well, can I put a 19? Well, I don't think so, because if I put 19 there, because I'm just starting with, the biggest numbers that I have left, there's no way for me to get a sum, or is there? Right? Because the 15 plus 4, but the 4 is over here, right? And then 6 plus 13 could do it. Right, that would work. But then what number goes in here? Right? Because if you have that kind of a scenario, 6 plus 19 is 25. Can't put a 25 there. 6 plus 13 is 19 again. So that doesn't work. Okay, no problem. Can't put a 19 there. Okay. If I can't put 19 there, what can I put? Let's try the other end, which is this end. 11? Well, I think so. 6 plus 5 gives me 11. That works so far. Let's go with that. We don't know, but that's what trial and error is all about. Now we get to the last two. We got to choose one of these remaining numbers to fit in there in this box, and then another remaining number to fit in there. Let's see here. 11 plus 6 is 17. Well, 17 is already here, so that's no good. Let's see here. If I put a 13 in here, 13 is one of the numbers that is still available. And then 13 plus 6 is 19. 19 is a number that's available. Okay, that all works out. Yeah, so I think I'm going to stick with that. So now what do I have left? 1, 2, 3, 4 numbers in 4 boxes. Okay, I hope this works. So 22 is there. So this number plus 2 can give me 22. Well, that number would have to be 20, and 20 is already there, so that's no good. So that makes me think that this number plus this number gives me 22. Okay, with the remaining numbers here, which two would add up to give 22? Well, my remaining numbers are 10, 12, 14, and 18. The answer is obvious. It's 10 and 12. But where do I put the 10 and where do I put the 12? Do I put the 10 here and the 12 here? Or do I put the 12 there and the 10 here? Right? That's a little bit of a dilemma. Okay, let's figure this out. If I put the 10 here and the 12 here, I will be able to get the 22. That's not a problem. But how will I get the 10? How will this 10 be made? Well, 2 plus 8, but 8 can't go there. 3 plus 7, but the 7 can't go there. So that 10 can't go there. So most likely it's a 12 here and the 10 there. Because 2 plus 10 gives you 12. So that fits perfectly well there. And then what about this number here? Well, 12's already gone, 10's already gone. Let's see here. 2 plus 8 is 10. 9 plus 8 is 17. 8 plus 10. 8 plus 10. There you go. That gives me 18. And therefore, there's only one number left, 14. And that must go there. And let's just make sure. How can we get the 14 with neighbors? 12 plus 2, that would give me 14. There you go. 14 is the number that goes in the question mark. So as you can see, it's a few guaranteed ones. And if I remember, the guaranteed ones were 17, 16, and 15, if my memory serves me correctly. And the rest of the diagram was sort of trial and error, trying to figure out how this will work, what fits, what doesn't fit. If I have an answer, which box does it go in? So as you can see, there's no 100% system. It's really trial and error, working it out. Don't get discouraged. If you get it wrong, no problem. Erase it and try again. So number 25, the answer is 14, and that would be choice C. A rectangular piece of paper ABCD is folded so that edge CD lies along edge AD, making a crease DP. It is unfolded and then folded again so that edge AB lies along edge AD, making a second crease AQ. The two creases meet at R, forming triangles PQR and ADR, as shown. If AB is 5 and AD is 8, the area of quadrilateral DRQC is in centimeters cubed. DRQC, so we're interested in that right there. So I blew the diagram up a little bit. DRQC, this is what we are interested in. And the first thing I can do is just break this up into two sections like that. And if you do, half of it, or not maybe half of it, but at least part of it will be quite easy. This is AB, and that's 5. And they tell you that AD is 8. So immediately we can label those. Now, notice in this diagram right here, up here, that CD was here. And then you folded it and CD came up here. So when you do that, what you've basically done is formed a square. And because you formed a square, this is the same as that in terms of its length. Correct? So basically what that means is that since AB is 5, CD is 5, right? Because this is a rectangle. And when you folded it up and CD kind of came up here, right? This was CD. If you look at it from that perspective, that CD is also going to be 5. Correct? So that means that from here to here is 5. And since P is exactly across, like if you were to draw a line across like that, P is exactly across, that means from P to C is also 5. So if I were going to draw a distance, that's also 5. Okay? So that's the first thing you have to establish. And in a very similar way, for this crease that brings it to Q, it's exactly the same. From B to Q, it's also 5. Okay? Now that allows us to figure out the distance from B to P. If this whole distance is 8 and this distance is 5, then that means B to P is 3. And in a very similar way, you can figure out that Q to C is also 3. And therefore P to Q, that distance, is 2. Okay? So the very first thing in this red quadrilateral we can figure out is the area of this triangle right here. So that triangle, which is DCQ, is just 1/2 base times height, and the base is 5 and the height is 3, so that's 7.5. Okay, now we have to figure out this triangle right here. To figure out that triangle, what I'm going to do is first figure out the triangle PQD, which is this guy right here. PQD is right there. From that, I will subtract this one, PRQ. So PQD minus triangle PRQ, and whatever that is, I will then add to the 7.5, and therefore I'll got my answer. Okay, PQD is 1/2 base times height. The base is PQ, which is 2, and the height, I can use this distance, D to C. So that's 5. Now we come to not necessarily the most difficult, but definitely a little bit of thinking involved here, PRQ. How do I figure out the area of PRQ? I have the base, that's 2, that's not a problem. But the height, from there to there, how do I figure out the height? Well, I'll just draw in the height in red. First, let me remove that 2 there. Okay, so we're going to need to draw in the height. So here's the height right there. Okay? And let's blow this up a little bit. Now, how do I figure out that height, that red line? Well, this is where angles come in. This angle right here is going to be needed. How do I figure that out? Well, remember, this essentially, when it was folded, formed a square. So that crease is the diagonal of a square. So if you were to look at that angle is 45 degrees. And because it's 45 degrees and this is a right angle, this is also 45 degrees. So this is an isosceles triangle where this side is the same as that side. And this whole side was 2, so therefore half of it from here to here is 1. And therefore this is also equal to 1, since it is the other side of the isosceles triangle. So there you go, you just got your height. Height is 1. So I can now figure out the area of PRQ. PRQ is 1/2 base times height. The base is 2, and the height is 1. And that looks like it equals 5 minus 1, which is 4. So now to figure out the quadrilateral DRQ, I just have to add this, and if I do, I get 11.5. And therefore, the answer to number 25 is D. It has 2 candles, one of which was 32 centimeters longer than the other. She lit the longer one at 3 p.m. and lit the shorter one at 7 p.m. At 9 p.m., they were both the same length. The longer one was completely burned out at 10 p.m. and the shorter one completely burned out at midnight. The 2 candles burned at different rates, but constant rates. What was the sum of the original lengths of the 2 candles? So I've got candle number 1 and candle number 2. I'll let the original length of candle number 1 be x, and candle number 2, the original length, was x plus 32. So this question is telling me to find the sum of the original lengths, which will be x plus 32, which is 2x plus 32. So obviously I have to figure out the value of x. Before I begin, I'd like to explain this question a little bit as to how to approach it by giving it some numerical values. Let's say my candle is 20 centimeters long, and the rate at which it burns is 2 centimeters per hour. And I ask you, after 2 hours, what is the length of the candle? Well, it would be 20 centimeters minus 2 times the rate, which is 2, right? So that's going to be 20 minus 4, which is 16. So after 2 hours, the candle is only 16 centimeters, all right? So with a numerical example, I hope you can understand how we're going to do this. So first, before I get into the rates, let me just write out the times. So at the very beginning, we've got x and x plus 32. And the very beginning for candle number 1 is 7 p.m. The very beginning for candle number 2 is 3 p.m. All right. Now they are moving forward a little bit, and they're saying 9 p.m. for candle number 1. And they're saying that at that point, they are both the same length. All right. So I'll call it Y. I don't know. I have no idea what the length is. So we'll just say Y because they're both the same length. Therefore, I can call both of them Y. And then at the very end, they're saying that eventually the length becomes 0. So for candle 1, that happens when? Shorter one completely burned out at midnight. So 12 a.m., right? Midnight is 12 a.m. And then 0 for candle number 2, which is 10 p.m. Okay, so that's the setup, right? Okay, now we're going to get to this whole story right here. So for C1, we have X for the original length. But then after 2 hours, from 7 to 9 p.m. is 2 hours. What will be my length? Well, exactly what I did here. It will be X minus 2 times the rate. And I'll call it rate 1 for candle 1. And that is equal to Y. Okay? Nothing fancy, just exactly what I did over here. And then similarly for C2, that is 6 hours, right? 3 p.m. to 9 p.m. It'll be X plus 32 minus 6 times R2, where R2 is the rate that the candle 2 burns at. All right? And then for this guy right here, 0, that is 7 to 12 is 5 hours. So it's X minus 5R1 is equal to 0. And then for this guy, it's 3 to 10, which is 7 hours. So X plus 32 minus 7R2 is equal to 0. So these are our equations that we are going to use to solve. All right, so here we go. Let's solve this now. In any order is perfectly fine. I immediately see this as being very helpful, that X is going to be equal to 5R1. Okay, and that's going to help me out, I hope. And this is what I'm going to do. Since these are both equal to Y, I set them equal to each other. So we get X minus 2R1 is equal to X plus 32 minus 6R2. All right. Well, get everything in terms of X if possible. R1 I can get in terms of X. It's going to be X over 5, like that. And this is X plus 32 minus 6R2. R2, yeah, I can get in terms of X with this equation. So that's going to be, let's see here, X plus 32 is 7R2. So that means R2 is X plus 32 over 7. So X plus 32 over 7, like that. Okay, so now we just have to solve this. Multiply everything through by 35. That'll help get rid of both fractions. And if you do, you get 14x, and this will be 35x, like that, plus 1120 minus 6x plus 30x minus 960. Okay, and then if you collect like terms, you get 16x is equal to 160, and therefore x is equal to 10. There we go. So going back to our original, 2x plus 32 looks like 20 plus 32, and that is 52. So there we go. Number 25, the answer is E. A list of 6 positive integers p, q, r, s, t, u satisfy that p is less than q, less than r, less than s, less than t, less than u. There are exactly 15 pairs of numbers that can be formed by choosing 2 different numbers from this list. The sums of these 15 pairs are as follows. Which sum equals r plus s? Well, our 15 pairs, we can write them out pretty quickly. P plus q, P P plus R, P plus S, P plus T, and P plus U. And then Q plus P does not need to be written out because that's only counted once. So we just have to write unique pairs. Q plus R, Q plus S, Q plus T, and Q plus U. And you keep going like this. There's only a few left. R plus S, R plus T, R plus U. And the last three, S plus T, S plus U, and the last one, which is T plus U. Now, what I initially thought, which is not correct, is that this is all in sort of order. So, for example, this is 25, this is 30, this is 38, and so on, right? And that is tempting because you think, oh, I can do this really quickly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I just have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, R plus S is 76. Circle that and move on. But that's not the right way of doing it. I know that is very tempting to do, and I initially thought about doing that, but then I quickly realized, no, that's not going to be the case. What you do is you add up all of these. And when you do, it's actually pretty straightforward. It's just 5P plus 5Q plus 5R plus 5S plus 5T plus 5U. And when you add up those, they all have to equal that, right? Because we don't know the order, but we know that all of these guys represented by those guys. We don't know which one is which, but the sum will be the same. And when you do add up all these guys, it's pretty straightforward math. It's 980. Now, if you factor out a 5 from each of these, you get just P plus Q plus R plus S plus T plus U, right? And then if you divide through, you get that this will be equal to 196. All right, so now where do we go? Well, at this point, there is some good news that the smallest possible is going to be P plus Q. The rest, in the middle, we're not sure. But the smallest must be 25, right? And similarly, the largest is also something that we can be assured is T plus U. So the largest must be 117, this guy right here. So this was the smallest, this is the largest. The other ones, I'm not sure, they might overlap a little bit. So that means if you go back to this and this, we can substitute in 25 for P plus Q and 117 for T plus U. And that will give me R plus S is equal to 196 minus 25 minus 117. And therefore R plus S is equal to 54. So as you can see, it was not 76 as I had previously, thought. It's actually 54. And therefore number 25, the answer is B. In a sequence of 10 terms, the first term is 1, the second term is x, and each term after the second is the sum of the previous two terms. For example, if x is 11, the sequence would be 1, 11, 12, 23, 35, 58, 93, 151, 244, 395. For some values of x, the number 463 appears in the sequence. If x is a positive integer, what is the sum of all the values of x for which 463 appears in the sequence? We have the first term, second term, third term, fourth term, and so on, right? Good news is we only have 10 terms. And much better than having 100 terms or infinite terms. Now they tell us the first one, they give us that is equal to 1. Okay? The second term they tell us is x. And then every term after that is the sum of the previous two. So the third term would be obviously 1 plus x. The fourth term would be this plus this, which would be 1 plus 2x. The fifth term is this plus that, which is 2 plus 3x. And so on, right? So I'll just fill them all in. We've got here 3 plus 5x And then we have 5 plus 8x, and then 8 plus 13x, 13 plus 21x, and the last one would be 21 plus 34x. So as long as you don't mess up on the math there, this should be fine. Now, we want 463 to appear. How do we do that? Well, for the first one, obviously, it's set as 1, so that can never be 463. But if this one was set as 463, then that means that 463 has appeared somewhere. Okay, so that's one possible value for x. Okay, we'll circle it and keep it. What about if my 463 in a different sequence, not this one of course, but in some different sequence, if this value was 463? If that is the case, what is my x value going to be? Well, x would be 462. Okay, I'll keep that as a possible value of x. In another sequence, if this was set to 463, then that would mean 1 plus 2x is 463. And then solving, you get 2x is equal to 462. And therefore x is equal to 231. Okay, great. I've got another value. Let's keep going here. In another sequence, if that fifth term, 2 plus 3x is 463, then let's see what we get for x. Now that means 3x is equal to 461. And therefore x would be about 153.6. Now this we don't include. Why? Because they only want positive integers for values of x. So if it's not, that's not something that I can include in my sum. Okay, no problem. Let's keep going here. In the same story, basically, we're going to set all of these to equal 463 and then solve for x. And if it's an integer, we keep it as a possible value of x. So doing this one, 3 plus 5x is 463. 5x is equal to 460. And therefore x is equal to 92. Okay, that's an integer, so I keep that. All right, keep going here. This now is going to be equal to 463. And if you do the math, you get 8x is equal to 458. And therefore, x would be equal to approximately 57.2, I think. 57.25. So we don't include that because that's not an integer. All right, we have a couple more, or 3 more actually. 8x plus 13 is equal to 463. If we do that, we get 13x is equal to 455, and therefore x is equal to 35. Okay, great. We keep that one. And then we got a couple more. So now that, if I set that equal to 463, I get 21x is equal to 450, and therefore x would be equal to 21.4, not an integer. And then finally this guy, if I set that equal to 463. I've done it so many times, still can't remember. And that would be 463 minus 21, which is 442. And therefore x here is equal to 13. Okay, got another integer. So now my task is to add up the values of x that I got. So this one, this one, this one, this one, this one, and that one. And when you do, you get a grand total of 1296. And therefore number 25, the answer is B. Daryl first writes the perfect squares as a sequence: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. After the number 1, he then alternates by making 2 terms negative, followed by leaving 2 terms positive. Daryl's new sequence is 1, negative 4, negative 9, 16, 25, negative 36, negative 49, 64, 81, negative 100, and so on. What is the sum of the first 2011 terms in this new sequence? Well, obviously, you're not going to write out 2011 terms and then make a sum of all of those. What we have to do in this question is create a table and find some sort of a pattern, hopefully sooner rather than later, and then extrapolate that pattern to the very end. So here we go. So this is going to be n squared, and I'm going to write n and n squared, and then the cumulative sum, and let's go. So 1, 2, 3, I'm going to write, I think the first 20 to 25 should be sufficient. And then for each n, I will write the n squared. So of course 1, 4, 9, 16, 25, and so on. Now let's talk about the positive and minus type of signs. The way they're doing it is the first one is positive, but then the next two are negative. Then the next two are positive, then the next two are negative. The next two are positive, next two are negative, and so on. That is how they alternate the signs. So let's just fill those out real quick, and then we will talk about the cumulative sums. Now, at every stage in here, we have to add up a sum. So, for example, for n equals 1, we only have one number so far. The cumulative sum is just 1. But then now, we got to add these two. 1 minus 4. So now we are at actually minus 3. Then we add the next 3. And that brings me to minus 12. And then we add all of the first 4. And now I'm up to positive 4. Add 25, I'm up to positive 29. But when I add negative 36, I drop down to minus 7. And so on. You just keep adding the cumulative sums. So I'll fill all those out. Now, we have to look at these cumulative sums and see if there's any kind of pattern, right? And at first it doesn't seem like it. It's all sporadic. It's all over the place. But if you look at this closely, I was able to spot a pattern. You got a 4, 8, 12, 16, 20, 24. And the great thing about this is that it matches perfectly with the corresponding n. It's not even something that you really have to think too deeply about. It's perfect, matches exactly. So we are in a great position now, of course, to extrapolate all the way to the very end. And I think we don't need too many. I think our last one is 2011. So 2010, 2009, 2008. Because every fourth one, you'll see, is where you get this pattern. So as long as something is divisible by 4, as long as an n is divisible by 4, that pattern should happen. And 2008 is divisible by 4. So it should have that pattern, and of course it will. That n squared, 2008 squared is 4032064. But what we are most interested in is the cumulative sum. Well, the cumulative sum for 2008 will be 2008. And that's the great thing about this question, that it matches so perfectly. Now let's write down the n squareds for each of these n's. 2009 squared is 4036081. And then 2010 squared is 4040100. And the last one will be 4044121. All right. Now, the last part of this question is trying to figure out the plus minus signs, right? Because these are not always going to be pluses and minuses. They're going to be a combination. And just in a careful way, look at it. Start with the 4, right? If you start with the 4 and just look at these 4 guys, it's plus, plus, negative, negative. Start at an 8. It's plus, plus, negative, negative. Start at the 12. Plus, plus, negative, negative. So that means if you started here, these will also be plus, plus, negative, negative. So the first 2 are plus, and then we have negative, negative. Okay? So now all we have to do is figure out the cumulative sum. So let's do this one. That's going to be 2008, my cumulative sum, plus this number. That sum is 4038089. And then you take this and add to it this number, keeping in mind that that number is negative. And when you do that, you get a sum of minus 2011. And then take this and add to it that, not confusing the negative signs. And when you do, you get minus 4046132. And that is your cumulative sum, 4046132 negative. And therefore, number 25, the answer is E. So number 24, the answer is E. In the rectangle WXYZ, the parallelogram PQRS is formed as shown. The segment PT is perpendicular to SR. The length of ST is. They want you to find the length of that small segment ST. Okay, well, several ways of doing this question here, but one way is just to look at the areas. The total area, TA, of the entire big rectangle, we can easily figure out. Length times width. The length is 3 plus 12. Those dimensions have been given. And the width is 4 plus 5. So very quickly, we get this is what? The 15 times 9. And that is 135. So that is the area of the full rectangle, the big one. Now I want to concentrate on the area of that parallelogram. Well, that is PQRS, and the area of the parallelogram is going to be the total area minus these little triangles. So if I take the total area and subtract that triangle, this triangle, this triangle, and this triangle, I'll get what's left, which is the PQRS. So total area minus the 4 triangles. So this triangle and this triangle are the same. So it's really 2 times those 1/2 base times height, since they have both the same dimensions. And then this triangle and this triangle are also the same. So instead of subtracting them individually, I can just combine them. 2 times 1/2 base times height, which is 12 times 5. Well, total area I just got was 135, and this looks like 12 and 60. So 135 minus 12 minus 60, and that is 63. So that is my area of PQRS. Now, the area of PQRS can be calculated by length times width, or length times height. This is the length, and this is the height, since PT is perpendicular. PT is perpendicular, and therefore it can be used as the height. So PQRS, the area, is PQ, which is the length, times PT, which is that height, since it's perpendicular to SR. Well, PQRS we know is 63. PT, we don't know that. That is something we obviously will need to figure out. And PQ, we don't know right now, but I can figure out PQ pretty easily using Pythagoras, using this triangle right here. So PQ squared is 12 squared plus 5 squared. And that's 144 plus 25. And that's 169. So take the square root to get PQ, and that's 13. So 13 goes here. So that means PT is 63 over 13. But they don't want PT, they want you to find ST. ST is right here. Well, that shouldn't be a problem. I can use that triangle in the Pythagorean relationship. So my final step, I've got PT squared plus ST squared is equal to PS squared. Now PS, we haven't calculated yet, but we can do that easily using Pythagoras. Some of you even remember what that is. If one side is 3 and the other side is 4, what is the hypotenuse? But just in case you didn't, we can do it really quickly. 3 squared plus 4 squared is equal to ps squared. That means this is 9 plus 16, which is 25. 25 is ps squared, so ps must be 5. So there we go. So ps squared is going to be 25. And then pt we just figured out was 63 over 13 squared, and then st squared. So st squared is going to be 25 minus 63 over 13, all squared, like that. Okay? And you can do this in fractions or you can do it in decimals. It doesn't matter. In the end, as long as you choose the right answer, that's all that matters. I did it in decimals, actually, and I get st squared to be 1.5147. And then if you take the square root, I got st is equal to 1.23 approximately. And of all the answer choices, the one that matches 1.23 is choice D, 16 over 13. If you did this in terms of fractions, you would get exactly 16 over 13. It's up to you, whichever way you feel most comfortable. So number 20. At the beginning of the winter, there were at least 66 students registered in a ski class. After the class started, 11 boys transferred into this class and 13 girls transferred out. The ratio of boys to girls in the class was then 1-to-1. Which of the following is not a possible ratio of boys to girls before the transfers? Let's discuss this now. Our total number, they're saying, has to be at least 66. And that number, of course, is the number of boys plus the number of girls. And that's got to be greater than or equal to 66 initially. Then what happens is the number of boys increases by 11 and the number of girls decreases by 13. And when it does, this ratio becomes 1-to-1. So that basically means that b plus 11 is equal to g minus 13. And if you put everything on one side, you get b is equal to g minus 24. So this is a very important formula. But we also know that b plus g has got to be greater than or equal to 66. Okay? So what we can do is what I did, is look at the answer choices and work through them. Otherwise, we'd have to make a table, and that table will go on forever. I mean, that table is going to take forever. I mean, we're going to have to put so many values in. And also, we don't know how long to keep going. Even if you say you make a table and start eliminating, and you eliminated, like, say, 3 of them, when do you stop? You have to keep going until you eliminate 4, but what if you can never eliminate the 5th one? You just keep going, or it'll be just a mess. So what we're going to do is just use the answer choices. The answer choices basically are the ratio of the boys to girls. So the ratio of the boys to girls is obviously b over g. That's all that is. At the very beginning, right? Before the transfers. Well, we figured out this nice formula. So instead of b over g, we can put g minus 24 over g. And this is something we can use. So we will use that for each of these. So let's start with 4 over 7, our first answer choice. If g minus 24 over g is 4 over 7, cross multiply, you get 7g minus 168 is 4g. And therefore 3g is equal to 168. And therefore g is equal to 56. Substitute that back into here, that value for g. And when you do, you get b is equal to 56 minus 24, which is 32. Okay, now you say, well, those work in terms of integer values, but how do I know that that's, good to keep? Like, how do I know this is a possible? Well, you have to add up b plus g. And that gives me 88. And does that satisfy this? Sure it does. So this is legitimate. This is a possible value. So this is obviously not the correct answer because we want to find out something that does not work. That does work, we cross it off. Okay, so that's basically what we're going to do with all the answer choices. So here we go. Next answer choice is 1 over 2. So that's same thing, g over 24 over g is 1 over 2. That means 2g minus 48 is g, and therefore g is 48. And therefore, once you substitute g into there, you get, g into there, you get b is equal to 24. Now let's figure out b plus g, and that is 72. Does that satisfy this guy? And the answer is sure. So that is also possible. So we cross that out because we want the one that's not possible. All right, let's keep going. So our next one is 9 over 13. So same thing, g minus 24 over g is 9 over 13. Let's see if this works. All right, 13g when you cross multiply minus 312 is a 9g, and that means 4g is 312, and that means g is 312 divided by 4 was 78. And therefore b, if you substitute it back into there, would be 54. And therefore now we have to verify b plus g is 132. So it definitely satisfies that one. All right, great. They're making us work here. I think purposely put the answer either D or E just to make us do more algebra. All right, no problem. Well, we're down to the last two. Obviously, one of these last two has to be the answer. So, and I have a feeling that it might be E because they want us to work. But let's see. It doesn't really matter. We can do it. So the next scenario, we got g minus 24 is g, and that's 5 over 11. And we got 11g minus 24 times 11 is what? 264. And then we got 5g. So we have 6g is 264, and therefore g is 44. Substitute it back into here, and we get b is equal to 20. Now let's do that b plus g test. B plus g would be 64. Oh ho! That does not satisfy that. So D is not possible. Okay, great. That's the correct answer. And just for the sake of completion, let's just do this one, just to be complete. It won't take us that long. So by now you're an expert. G minus 24 over G is 3 over 5. So that means 5G is minus 120 is 3G. And therefore 2G is 120. And therefore G is 60. And then B would be G minus 24 would make it 36. B plus G is 96, and that satisfies that equation. So this is also possible. Therefore, in a very complete way, we have arrived at the answer, which is D for number 25. Residents were surveyed in order to determine which flowers to plant in the new public garden. A total of N participated in the survey, N people. Exactly 9 over 14 of those surveyed said that the color of the flower was important. Exactly 7 over 12 of those surveyed said that the smell of the flower was important. In total, 753 people said that both the color and the smell were important. How many possible values are there for N? Well, we need to create a little bit of a Venn diagram. And don't worry, it's not that bad. And I'll explain what I'm doing here. So first and foremost, let's talk about the fact that we have N as our total number of people participating. And I will call this A, B, and C, those sections. And this circle represents the color, the people who felt that the color was important. And this circle represents the people who felt the smell was important of the flower. So now we are told a few things. That A plus B, which is all the people in the color circle, represent 9 over 14 of N. And we are also told that B plus C, which are all the people in the smell category, the people who felt that smell of the flower was important, that is equal to 7 over 12 of N. All right. Now, one thing you'll notice is that these are all integers, right? A, B, and C represent the number of people, so they have to be integers. So the only way they can be integers if n is a multiple of 12 and a multiple of 14. So 12 and 14 is what n has to be a multiple of, both of those. So we have to find the least common multiple of 12 and 14. Well, 12 is going to be 2 times 2 times 3, and 14 is 2 times 7. So the least common multiple is 2 times 2 times 3 times 7, and that's 4 times 21, which is 84. So n is of the form 84k. It's got to be some multiple of 84. That's the only way we can make that an integer and that an integer, because A, B, and C are integers. Okay, so now that that is established, let's plug in that value of n. 9 over 14 times 84k. And when you do, you get 54k for A plus B. And when you do the same thing over here, you get B plus C is equal to 7 over 12n, which is 84k. And that gives you 49k for B plus C. All right, so now that that is established, we now look at this part, which says that 753 people said that both color and smell were important. That number represents B. So B is 753. So that means A is 54k minus B, which is 753. And C is 49k minus B, which is 753. So now let's complete this Venn diagram with the values. Well, B they gave me in the question, 753. A I just figured out was 54k minus 753. And C was 49k minus 753. Okay, great. Now we have to figure out how many possible values are there for n. Okay, so that means I got to figure out a upper and lower boundary for my k. So we will first do the upper, and then we'll do the lower, and then we will combine them. So what is going to be the first limit? What is k greater than? What is what is k going to be greater than? That's going to give me sort of the lower limit. Well, we know that A is equal to 54k minus 753 and C is equal to 49k minus 753. And both of those obviously have to be integers, so both of them have to be positive. So that's what gives us our lower limit. 54k minus 753 has to be greater than 0. From this, you can get that k is greater than 13.9. And then the other one, 49k minus 753, that's also greater than 0. So that gives me that k is greater than 15.3. So combining these, k has got to be greater than 15.3. So k is greater than or equal to 16, because k has to be an integer also. It represents the value of n, and n is also an integer because n represents the number of people. So this is our lower limit right here. K has got to be at least 16. Upper limit. Well, upper limit is looking at the fact that A plus B, as we figured out, was going to be 54k, right? We did that right here. A plus B is 54k. And that represents what? The number of people who felt that color is important. So color is important. So the total is 84k. 54k said the color is important. So 54k said color is important, so 30k, which is 84 minus 54, must be the people for whom color is not important. Right? So that is the first part of this. So no tricks here. That's just simple sort of analysis of these numbers. Now let's turn our attention to this guy right here, which is the people in the smell category. They are basically the people of B and C, B plus C I should say, and that is 49K. Now, these 49K people include some of these 30K, some or all of these 30K people. So let me write that out because that's an important point. These 49K people include some or all of the 30K people who said that color was not important. So that means that B basically would be equivalent to 49K minus 30K, and therefore that is 19K. And considering this statement, we can conclude that since B is 753, that 753 must be greater than or equal to 19K. And if you do the math here, K becomes less than or equal to approximately 39.6. So in terms of integers, that means that K has got to be less than or equal to 39. So combining, that means K is going to be greater than 16, but less than or equal to 39. Greater than or equal to 16 or less than or equal to 39. So every number from 16 to 39, and that gives me 39 minus 15, which is 24 possible values for K. And each value of K gives me one corresponding value of N. So that's 24 values for K, 24 values for N, and therefore number 25, the answer is D. The alternating sum of the digits 63195 is 6 minus 3 plus 1 minus 9 plus 5 is equal to 0. In general, the alternating sum of the digits of a positive integer is found by taking its leftmost digit, subtracting the next digit to the right, adding the next digit to the right, then subtracting, and so on. A positive integer is divisible by 11 exactly when the alternating sum of the digits is divisible by 11. For example, 63195 is divisible by 11 since the alternating sum of its digits is equal to 0, and 0 is divisible by 11. Similarly, 92807 is divisible by 11 since the alternating sum of the digits is 22. But 60432 is not divisible by 11 since the alternating sum of its digits is 9. Lin forms a 7-digit integer by arranging the digits 1 through 7 in random order. What is the probability that the integer is divisible by 11? All right. So it's a probability question, so it's going to be some fraction. Something over the numerator over the denominator. And the denominator is the total number of cases. So we have 7 digits. So 1, 2, 3, 4, 5, 6, 7. For the first digit, we can put any of the 7 choices. 6 choices for the next one, because they all have to be different digits. And so on, 5, 4, 3, 2, 1. So the total number of combinations of numbers that you can make is this, which is essentially 7 factorial. And 7 factorial is 5040. So that's the total. And therefore, because it's a probability question, that goes in the denominator. And now our task in this question is to figure out what is this numerator. Okay, so the numerator is a specific condition. And I'm going to call the numbers letters. So A, B, C, D, E, F, and G, right? 7 letters. Now the alternating sum is as follows. It would be A minus B plus C minus D plus E minus F plus G. And if you group this with the positive and the negatives, it would be A plus C plus E plus G. And then from that, you're subtracting B plus D plus F, right? And we want this alternating sum to be divisible by 11, so it has to equal 11K, where K is greater than or equal to 0. Or K can be anything, really. It doesn't have to be positive. Some K, some integer K. 0, 1, 2, whatever. Okay, So that's the setup of the question. So the first thing I'd like to do is figure out what is the total sum. If I added 1 plus 2 plus 3 all the way to 7, the total sum of 1 plus 2 plus 3 all the way up into 7 is 28. All right? So with that, I'm going to make a table. So the first entry is this guy right here. A plus C plus E plus G. And the next entry is this guy right here. B plus D plus F. And the difference between those two is basically right here. And then we're going to figure out what is K. Okay. So because the total is 28, whatever we put for this guy, the total is 28. So this is going to be 28 minus this. So for example, the smallest, or let's say the largest, let's start out with the largest. The largest it can be is if A, C, E, and G are these numbers, right? The largest ones. And that largest, 7, 6, 5, 4, if you add them together, you get 22. And then the other three, which obviously would be 3, 2, 1, that would be 6. So very quickly, you can put in the first. And the difference, 22 minus 6, is 16. Now, is that divisible by 11? No. So I'd put a dash there. So you see how I'm doing this? And we just have to keep doing this. So 21, 7, 14, it's not divisible. 20, 8, 12, not divisible. 19, 9, 10, not divisible, and so on, right? So I'll just fill this in. Obviously 18, 17, 16, 15, 14, 13, 12, 11, and 10, which is the smallest sum of 4. These 4 are the smallest sum if I used these smallest numbers. And then the other column is pretty much always going to go up by 1. It's pretty easy. You're just subtracting from 28. Subtracting this guy from 28. So 11, 12, 13, 14, 15, 16, 17, and 18. And the differences are pretty straightforward. 8, 6, 4, 2, 0, minus 2, minus 4, minus 6, and minus 8. Now, the only one, interestingly, where K actually has some integer value is this one right here. K is 0. So that's it. That's the only one out of all these. So, since it is the only one, we obviously have to pay close attention to that one. All right, so now the question is basically just looking at that one entry. So that one entry basically says that B plus D plus F is equal to 14. And the A plus C plus E plus G guy, that's also equal to 14. So we have to figure out scenarios. Okay, I'll just explain the first one in detail, and then I'll let you figure out the rest because it's identical. Okay, let's start with the smallest one. 1 is the smallest number. What can D and F be? Well, they can be 6 and 7. That would equal 14. Okay, but from these three, there's different combinations. There's 1, 7, 6, 6, 1, 7, 6, 7, 1, 7, 1, 6, and 7, 6, 1. As you can see, using just those three, we got 6 combinations. Now, each of these leads to a bunch of combinations here. If 1, 6, 7 were chosen for these guys, the other numbers, which are 2, 3, 4, and 5, have to be chosen for this. And that has a lot of combinations because if you are using, the same kind of story, you have 4 choices for the first number. You have 3 choices remaining for the third, 2 choices for the third. First choice we have 4, second choice we have 3, third choice we have 2, and for the last one we have just 1, right? So that actually equals 24. So what that means is that for each of these, you're going to have 24 possible combinations of these guys. So I'll just put that in here. I'll put it in red. 24 combinations. And similarly, there'll be 24 for this guy, 24 for this guy, 24 for this guy, and 24 here and 24 there. So that means if you add up these, this 24, this one, this one, this one, this one, this one, it's 6 times 24. For each triplet that I put over here, right? So, for example, for 167, it was really a total of 6 times 24, which is 144. Okay, so that's probably the most important part of the question, because the rest is pretty much all the same now. Okay, so our task is pretty much to figure out how many more of these do we have. Okay, so the next one for B, D, and F, these three guys, is something like 2, 5, and 7. But remember, there's going to be 6 of these. There's going to be 2, 7, 5, right? 5, 2, 7, 5, 7, 2, 7, 2, 5, and 7, 5, 2. And each of these, you'll get 24 for these guys, 24 combinations. And therefore, you will get, for this triplet, which is 2, 5, 7, a total of 6 times 24, which is 144. All right, so that's pretty much the story. Now, at this point, you're an expert, so I don't need to walk you through it, so I'll just list them. Okay, so let's list them now instead of walking you through it. The other triplets that work, 3, 7, 4. There's going to be 6 of those, and each of them will give 24, so a total of 144. So I'll just write that much, because by this point, you understand. The next triplet is 3, 6, 5. That will give you also another 144. Now, at this point, when we start writing triplets, we're going to get repeats. Another triplet is 4, 7, 3. But 4, 7, 3 is the same as that, so that is a repeat. So you don't include it. Next one is 4, 6, 4. Well, that's useless because you can't have the same number twice, so that's not even worth writing. 5, 7, 2. That's another one, but 5, 7, 2 is right here. It's a repeat. So I'll put repeat there. And as you can see, a lot of these are repeats. 5, 6, 3 is a repeat, right? Because 5, 6, 3 is right here. 5, 6, 3. It's right there. Okay, we got to find a few more. 6, 7, 1. That's a repeat. And then let's see here. 6, 5, 3. That is also a repeat. So I don't want to include those. 6, 3, 5. Well, pointless to put that in. I mean, that's obviously a repeat. Any more? 7, 4, 3. 7, 5, 2. 7, 6, 1. These are all repeats. Okay, so how many did I get that are not repeats? Let's circle them. I got this one, this 144, this 144, this one, and this one. So 4 times 144 is basically what I got. So put that in the numerator. So it's 4 times 144, and therefore this is 576 over 5040. In lowest terms, that is 4 over 35. And therefore, the answer to this question is E. In the table, the numbers in each row form an arithmetic sequence when read from left to right. Similarly, the numbers in each column form an arithmetic sequence when read from top to bottom. What is the sum of the digits of the value of x? An arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. For example, 3, 5, 7, 9 are the first 4 terms of an arithmetic sequence. All right. Well, let's label some things. Let's call this F, G, H, J, M, Q, and then we've got K and P. All right. So from this labeling, we can tell that we have an arithmetic sequence, but we'll concentrate on this column right here. So 40 is basically F plus some difference, D. And then K is 40 plus that difference. And then P is K plus that difference. From the first one, we can just isolate for F, 40 minus D. The second one we'll just leave as is. From the next one, P will be equal to, since K is 40 plus D, 40 plus D plus D, so 40 plus 2D. All right, so I think that's about as much as we can do there. Now let's concentrate on this row right here. F minus 43 is basically the difference there. And remember, the differences are different. That's why I'm calling it big D. But that's also going to be equivalent, since F is equal to 40 minus D. 40 minus D minus 43, which is negative 3 minus D. Okay? And then we look at the next term over. That term is F plus the difference in this case, which is big D. But big D and F, we know F is 40 minus D, big D is minus 3 minus D. So substitute those in. We get 40 minus D plus D minus 3 minus D. So this would be 37 minus 2D. And then H, which is right here, in a very similar way, we can say is F plus 2D. So it would be 40 minus D minus 6 minus 2D. So that's going to be 34 minus 3D. All right, great. So what we can do now is we can take this table and fill it with what we have discovered so far. So let's make a little table and fill in what we have. All right, so what can we fill in? Well, obviously we can fill in the numbers, those ones we know that are given in the question. And let's fill in anything else that we have discovered. Well, we got this as 40 minus D, 37 minus 2D, 34 minus 3D. And then 40 plus D and 40 plus 2D. And the other ones we don't know yet, N, J, and M, and Q. All right, so let's move forward. Now let's concentrate on another part of the diagram, and that is this column right here. So we'll say the common difference here is, say, D2. So that means 34 minus 3D minus 18 is that common difference. And that's going to be 16 minus 3D. Okay. Now let's look at each individual letter. J, of course, will be 18 plus 2D. And that's going to be 18 plus 32 minus 6D. So that is 50 minus 60. M is 18 plus 3D2. So that's 18 plus 3 times D2, so 48 minus 9D. So that's going to be 66 minus 9D. And then Q is equal to 18 plus 4D2. So that's 18 plus 64 minus 12D. So that's going to be 82 minus 12D. All right. Well, making some progress. So what we'll do is, again, we will take what we have found and fill this out again, this type of a table. So here we go. I have pretty much substituted all the values that we didn't have here, but now we do have. Okay, now we can concentrate on one final row, and that's the last one. We know something here that if we look at the difference here, this minus that has got to be the same as this minus that, since the differences are the same. So that means that 26 minus 40 plus 2D has got to be equal to 82 minus 12D minus 26. And both of these represent the common difference. So whatever you want to call it, D3, I guess. Okay, doing the math here, we get minus 14 minus 2D is equal to 56 minus 12D. So that means 17 is equal to 10D, and therefore D is equal to 7. So there we go. Now we can figure out these numbers. This guy, therefore, when we plug in D equals 7, will be negative 2. put that in here, equals negative 2. This number in here, when you substitute 7, is equal to 54. So that means the common difference, 26 minus 54, is negative 28. And therefore, that's how we got from 26 to negative 2. So we can now work backwards and figure out n and x. We have to take this number and, I guess, subtract from it the difference. So that would be 54 minus 28. And when you do that, you get 82. So this is 82. And then to get x, we have to take 82 and subtract from it the difference. And when you do, you get 110. So x is equal to 110. And then they want you to find the sum of the digits of x. Well, the sum of the digits are 1 plus 1 plus 0. And that is, of course, 2. So the answer to this question, number 25, is B. Brady is stacking 600 plates in a single stack. Each plate is colored black, gold, or red. Any black plates are always stacked below any gold plates, which are always stacked below any red plates. The total number of black plates is always a multiple of 2. The total number of gold plates is always a multiple of 3, and the total number of red plates is always a multiple of 6. For example, the plates could be stacked with 180 black plates below 300 gold plates below 120 red plates, or 450 black plates below 150 red plates, or 600 gold plates. In how many different ways could Brady stack the plates? The black plates are always a multiple of 2, so let's say 2n. The gold plates are a multiple of 3, so we will call them 3k. And then the red plates are a multiple of 6, so we'll call them 6m. Now notice I chose different letters because they are not necessarily the same letters. So now what we have to do is try to figure out all the different combinations. So let's begin. The first scenario, black, gold, and red, is when you have all the plates of the same color. So 0, 0, 600. 0, 600, 0, 0, 0, 600. So that's pretty straightforward to figure out. And as you can clearly see, there's 3 such ways of doing that. The next scenario or type of scenarios is when you have 0 plates of one color. So either 0 red or 0 gold or 0 black. And then we have to figure out how many are there of the other colors. The first scenario, when we have 0 red, that is going to be an equation that we have to work with. We only have black and gold, so that means 2n plus 3k is equal to 600, right? Because that is what we have to represent the numbers b, g, and r. Now, what we have to do essentially is figure out integer solutions for that equation. And we begin, and remember, in this table, I'm actually going to be putting in values for n and k because I'm looking at that equation. So here we go. Quickly figure out that n cannot be 0 because n has to be a number. N equals 0 in that scenario, but we're not dealing with that anymore. If it equals 1 or if it equals 2, we don't get an integer value for k. But when n equals 3, we do. We get 198. Okay, so this is going to be 0 all the way down. The next integer value that works for n and k are 6 and 196. And then you just keep going like that in a very predictable way. You just keep going and you can find that the end of the road is 297 and 2. So now we have to figure out how many were there. Well, if you divide this by 3, you get 1, 2, all the way to 99. And that quickly tells you that there's 99 of those. All right. So in the very same way, we're going to approach the next one. This time g is 0. So we have 2n plus 6m this time is equal to 600. Okay, well, 0 all the way down there. So now let's start with red equal to 1. And again, where I'm putting in values for n and m here. If m is 1, then I get for n 297. If m is 2, I get 294. And in a very predictable way, you just keep filling out those and you find out that the end of the road is 99 and 3. So how many did we get? Well, it's pretty easy to count this one. That's 99. All right, so now you're getting the hang of it. 3k plus 6m this time is equal to 600. Same thing, trying to get integer solutions. When you put in 1, you get 198 here. This is going to be 0 all the way down. When you get 2, you get 196 here. And then you just keep going like that. And the end of the road in this table is 3 and 99. Very easy to count. How many? 99. So there we go. So those ones are done. Now we get to a scenario where we have sum of all three colors. There's no zeros anymore. So I've got to figure out B, G, and R. All right, so if I put in 1, I quickly figure out that it's not going to work. Why? Because my equation is 2n plus 3k plus 6m is equal to 600. And that equation gives no integer solutions for n, k, and m when n is equal to 1. All right, let's try n equals 2. Again, it doesn't give me solutions, but when I get n equal to 3, I start to get integer solutions. And that means I've got to take into consideration that now n is fixed as 3. So this becomes 6 plus 3k plus 6m is equal to 600. And that means 594 is equal to 3k plus 6m, but I'm going to factor out a 3 to give k plus 2m, and then therefore k plus 2m is 594 divided by 3. And that is 198. All right, so now I've got to figure out integer solutions for this. And that's not that hard. When you start playing around with that, you figure out when k is equal to 2, that's how you get the first integer solution. It's 98. When it's 4, you get 97. And dot, dot, dot. You just keep going like that. And at the end of the road, you get 196 and 1. So what we quickly figured out is this took care of the 3's. And as you can clearly see, there's 98 of them. All right. So you keep going like this, and I'll do a few more so that you can get the hang of it. Let's now go to 4. When b is 4, we don't get anything. When b is 5, we don't get any integer solutions. But when when n is 6, you start to get integer solutions. So what are those integer solutions? Well, this 2n would become 12 plus 3k plus 6m is equal to 600. So that means 3, and let's factor it out, k plus 2m is going to be 588, correct? And then now we divide through by 3, and you get k plus 2m is equal to 196. So now we have to figure out integer solutions for this with n fixed as 6. And that's not too big of a problem. We know that k is not going to give you anything when it's 1, but when it's 2, you start getting integer values. And that first one is 97. When it's 4, it gives you 96. And then you just keep going. And at the end of the road, you get 194 and 1. So as you can clearly see, that gives you 97. And then you just keep going down like that. Dot, dot, dot. Right? And then at the very end, as you can see, the values for n, 3, 6, they're going up by. When you keep going, you get to 297 for n. So when n is 297, it becomes 2 times 297 plus 3k plus 6m is equal to 600. So this is, factor out the 3k plus 2m, and then 2 times 297 is 594. 600 minus 594 is equal to 6. K plus 2m is going to be therefore 2. So the only solution for here is going to be 1 and 1. All right, so that gives me only one solution. So what makes the most sense to me is that all of these guys look like 1, and then there was probably 2, and then 3, and then 4, and so on, 9, all the way up until 97, 98. So we have to add all these up now. All right, so when we add them all up, we had 3 here. We have 99 here, 99 here, 99 there. So 3 times 99. And then we had from here 1, and then like I have sort of deduced, 2 plus 3 plus 4 dot 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 all the way up until this 97, and then that 98. Okay, so this is 3 plus 297, and using the formula n times n plus 1 over 2 to add consecutive numbers, that can be 98 times 99 divided by 2. So that looks like 300, and then 98 times 99 divided by 2 is 4851. So and when you add it to 300, it becomes 5151. And that's it. So, challenging question. The answer to number 25, 5151, that is choice E. In the 2x12 grid shown, Ashley draws paths from A to F along the grid lines. In every path, there are 2 or more arrows arranged head to tail. The tail of the first arrow starts at A, and the head of the last arrow ends at F. 2 consecutive arrows must be perpendicular to one another. No 2 arrows can intersect at more than one point, and all arrows have different lengths. The path from A to F shown consists of arrows of 3 different lengths, left 2, up 1, right 11. How many different paths are there from A to F? So this is a question that involves a lot of trial and error, but hopefully we can create a little bit of a system here. So we got a lot of rules to abide by, and abiding by these rules, I'm going to break it up into basically 2 components. The first is the arrows that go either up or down, like that. And then, of course, the second component is the arrows that go right or left. So first, let's talk about all the different possible ways of going right or left, and that also satisfy those conditions. And here is that list. It's a big one, right? A big long list of ways of going right or left. And some of these you might say, well, it doesn't seem complete. You know, what about right 8? Why don't you have a right 8 and a right 1? Well, because the only way to have that is to add to it an up 1. And remember, all arrows have different lengths. This is length 1, this is length 1. Can't have that. So in a very careful way, you've got to come up with this list. And this list only takes care of the right left. So we have to now take this list and look at it in 2 ways. The first way is all the combinations that include just going up by 1. And then later, all the combinations that include going down by 1 and then up by 2. And that's the only way of doing this. So first, let's just concentrate on this guy. If you're looking at the ones where just go up by 1, that is going to include this right here. A. So it's going to be up by 1 and then right 9. And then you can also have right 9 and then up by 1. And then for B, you can also use it R2 up by 1 and then R7. Or you can do it R7 up by 1 and then R2. And then C, you can also use that in a very similar way. R3 up by 1, R6. And then you can flip the R6s, R6 up by 1, R3. Okay, D you can also use R4 up by 1, R5, and of course the flip, which is R5 up by 1, R4. And then E you can use, but E can only be used in one way. That is L2, which is left 2, and then up by 1, and then R11. And then F is also used, but only in one way, which is L3 up by 1, and then R12. And these are the only ones that work for this guy, up by 1. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I got 10 of those. I'm going to erase them because I need to now concentrate on this guy. Okay, so the ones that involved the up by 1, we got 10 of them. All right, so now we are going to concentrate on the ones that involve going down by 1 and then up by 2. And then, of course, a combination of these left and right moves. Okay, so here we go. There's a lot of these, so I will go through them. I'll go through them pretty quickly. So the first one will be D1, R9, and then U2. This one, there's no way to use the D1, U2 combination. So we go to C. C would give me the following four: R3, D1, R6, U2, or R6, D1, R3, U2. But then you can also get for this one two more if you put the D1 first. So for example, if you put D1, R3, U2, R6 like that, and then D1, R6, U2, R3 like that. So from this guy, let me just put it in brackets here. We got 1, and then for this guy here, we got 4. And similarly for D, for this guy here, D, there's no way of making a list there. But for E, there is. For E, we have 4 ways of making the list. So I'll just list them. So these are the 4 for E. And then F, this guy here, that gives me 2. And those 2 are going to be L3, D1, R12, U2, and D1, L3, U2, R12. And then you just keep going like that. So as you can see, it's very time consuming, and you got to make sure that you don't make any mistakes. So for G here, this guy, you get another 4. And then for H, you get another 4. For I, you actually just get 1. For J, you will get 2. For K, you will get 2. For L, you get 1. For M, you get 1. And then for N, you actually get 2 ways of doing it. And then for O, P, and Q, you get 1 each. And then finally, for R, you actually get 2. And then for S, all the way to the end, there's 1 way each. And the combinations of how to do it, meaning this type of terminology or this type, I'll let you figure that out. I don't think you need to hear me go through all of that. Now you have to add up all these guys. And when you do, you get 45. So for this guy, there's 45. So the total is this 10 and this 45, and that is a total of 55 for a very challenging question for grade 8. And therefore number 25 The answer would be B. PQS, PQRS diagonals PR and SQ intersect at O inside PQRS. SP is equal to SQ is equal to SR is equal to 1. And angle QSR is equal to 2 times angle QSP. Mark determines the measure of 12 angles that are the interior angles of triangles POS, POQ, ROS, and ROQ. The measures of each of these angles in degrees is a positive integer, and exactly 6 of these integers are prime numbers. How many different quadrilaterals have these properties and are not rotations or translations of each other? We need a big version of the diagram because this question is all about angle chasing. And angle chasing is very common on math contests, and they oftentimes put these kinds of questions in. So here we go. We are told that this angle is twice this angle. So I'll call this 4 theta and I'll call this 2 theta. That was given in the question. Now the rest I've got to figure out. But there's some good news. We are told that this is equal to that is equal to that. So they've got some isosceles triangles, right? So let's start with this one here. If this is isosceles, this is going to be equal to that. I'll just call them x for now. So from the first triangle, I know that x plus 2 theta plus 4 theta is equal to 180. So that means 2x is equal to 180 minus 6 theta, and therefore x is equal to 90 minus 3 theta. Okay, I'll put that in here, 90 minus 3 theta. And this one also, 90 minus 3 theta. Let's keep going here. We got quite a few angles to get. So where do we go next? We have another isosceles triangle, this one right here. And therefore this angle has got to be the same as that angle. This angle I called x, so this angle here I'll just call y. And therefore this was going to be x plus y, right? Because this angle is the same as that angle. Okay, again, angle chasing. So let's see, I guess we're using this triangle. So that means 2 theta plus x plus y is equal to 180. And x we actually know. So it's 2 theta plus 2x, but x is 90 minus 3 theta. So that would be 180 minus 6 theta plus 2y is equal to 180. So that means 2y is equal to 4 theta, and therefore y is 2 theta. Okay, that's a pretty good result. So that's 2 theta right there. And I guess x plus y would be 90 minus theta. So there we go. Okay, where do I go next here now? Might as well figure out this one. I'll just call that z, and by opposite angles, that's going to be z. Yeah, that's a pretty good way to go about this. And then we can just use this triangle. So in that triangle, more angle chasing, 2 theta plus 90 minus theta plus z is equal to 180. So let's see what that gives me. Z is equal to 90 minus theta. Okay. 90 minus theta. And this one also, 90 minus theta. Where do we go next here? W is the letter I guess I'll choose for this and this. Those will be both W's. W and W. And for W, I guess we can just use the whole way around, that everything is going to be 360. So 2W plus 2Z is 360. And then 2W, well, Z is this guy, 90 minus theta, so 180 minus 2 theta is 360. So 2W would be 180 plus 2 theta, and therefore W is 90 plus theta. All right, 90 plus theta for W. Do I have any? Yeah, I got to get this one and this one. Okay. All right. Okay, the good news is that's part of this isosceles triangle. Okay, that is indeed good news. So this angle here, I'll just call whatever V, and therefore this has got to be the same as this one. So this angle will be X plus V. And I think that's it. That would be the last one. All right, here we go. Last angle chasing formula. And which are we going to use here? I guess we can just use the big one, that whole triangle. So that means 4 theta plus x plus v plus x plus v is equal to 180. And then we figured out one of these, right? X, yeah, we figured out x a long time ago. So 90 minus 3 theta. So this is going to be 4 theta plus 2x, so that's going to be 180 minus 6 theta. Plus 2v is 180. So that looks like 2v is going to be equal to 2 theta, and therefore v is equal to theta. All right, that's a pretty good result. So I think I have them all. I have them all, and we'll just make a list now of all my angles. I've got, let's just keep the diagram in the picture here because I've got to use it. Let's see here. In this triangle, I've got 2 theta, 90 minus 3 theta, and w. And what was w? W was 90 plus theta. All right, 90 plus theta. And then in this triangle here, I have 4 theta, x, which was 90 minus 3 theta, and z, which is 90 minus theta. Okay, and then in this triangle, I've got v, which I just figured out was theta, and then x plus v, which I guess would be x is 90 minus 3 theta, and then v is theta, so 90 minus 2 theta. And then the other angle is w, and w is equal to 90 plus theta. And then the last triangle, which is this guy, those angles are z, which is, or y, which is 2 theta, and then z, which is 90 minus theta, and then x plus y, which is 90 minus theta. All right, great. These are the 12 angles. Now, there's 12 angles, but some of them are repeats, right? So, for example, theta is listed once. 2 theta is listed twice. 4 theta is listed once. 90 minus theta is listed 3 times, actually. Yeah, 3 times. 90 plus theta is listed twice. 90 minus 2 theta is listed once. And finally, 90 minus 3 theta is listed twice. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12. Okay. Now, the rule is that 6 of these must be prime. 6 of these have to be prime. And we've got to figure out how to do that. Okay, so let's make a table with these angles. Here we go. Now, I got to start somewhere, right? So I'm going to start with theta, and I've got to make sure that they're prime. So we're going to start with prime numbers. And the first prime number, of course, is 2. And then I'm just going to list prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and hopefully, I don't have to go beyond that. Now, here's the thing. This is a big table, and it's very time-consuming, right? The math is not that hard, but it's just time-consuming. But some of these I don't need to fill out. Why? Well, because 2 theta is not going to be prime. It's divisible by 2. It's 2 theta. 4 theta is obviously not going to be prime because it's divisible by 4. So I don't need to worry about those guys. 90 minus theta, 90 plus theta, that one I need to figure out. 90 minus 2 theta, you can factor out a 2. So that's going to be divisible by 2. That can never be prime, therefore. And 90 minus 3 theta is going to be divisible by 3. You could factor out a 3. So the only columns I need to figure out are this one, and this one. So that's what I'll do. So we got 88. And the math now is very easy, right? So it makes it very quick that we can do this. 85, 95, 83, 97, 79, 101, 77, 103, 73, 107, 71, 109, 67, 113, 61, 119. Now we want a situation where we have at least 6 primes. Okay, well, there's only one of these guys. 90 minus theta, there's 3 of those. And 90 plus theta, there's 2 of those. So if we have prime, prime, and prime, we'd have 6, because it'd be 1, 3, and 2. Okay, let's see. Which one of these are prime, prime, prime? And when I look through the list, I think we have a right here. This one, the 19 gives me, so does 23, and so does 29. Is there any more? And the 11 one, this one also. Yeah, that'll do it. This is divisible by 2, that's not prime. 9, this is divisible by 3, this is obviously divisible by 5. And 77 is obviously divisible by 7, so those are not primes. So that's it, I get 6. And if you keep going, you'll find that you won't get any more. All right, we're done. Time consuming, definitely. So 6 I got, and therefore the answer to number 25 would be choice D. Positive integers with 20 terms is called an FT sequence if each term after the second is the sum of the previous 2 terms. For example, if the first 2 terms of an FT sequence are 8 and 7, the sequence would begin 8, 7, 15, 22, 37, so on. For some positive integer m, there are exactly 2, 4, 1, 5 FT sequences where the first 2 terms are each less than 2m, and the number of odd valued terms is more than twice the number of even valued terms. What is the value of m? We have a long list of terms. Each term is one of this sequence of 20 terms. So it's a very long, so I'm going to put ... obviously. Now we have to start understanding what this question is actually asking us. We have to start with 2 terms. And with those 2 terms, we are going to create this sequence, which basically is as follows. If the first term is, let's say, A, the second term is B, then each term is basically an addition of the previous 2. So this would be A plus B, this would be A plus 2B, which is the sum of this and this. And then the next term would be the sum of the previous 2, which would be 2A plus 3B, and so on, right? Now, we are told a very interesting point that the number of odd valued terms is more than twice the number of even valued terms. All right. At first, you think, okay, what does that even mean? Well, of these 20 terms, you're going to have a certain number that are odd and a certain number are even. So let's say of the 20 terms, x of them are odd, and therefore 20 minus x, the remaining terms are even. So what that sentence really means is that x is greater than 2 times 20 minus x. This sentence right here, the number of odd valued terms is more than twice the number of even valued terms. So we have to basically concentrate on odd and even in this question, interestingly. What the numbers are in terms of their numerical value is not really that important. What's important really is just whether they're odd or whether they're even. So let's first talk about what happens when you add 2 numbers. If you add 2 numbers and they're both even, even plus even is even. If you add 2 numbers, one is even and one is odd, the result is odd. If you add, again, 2 numbers and then you just reverse the order, the result is the same. And then finally, the last one would be 2 odds added together, and that result, interestingly, is even. So this one we don't need to worry about, because if we're going to just put even and then the result is even, so for example, if this was even and this was even, then the result is even, then again you get even and even, you just keep getting even numbers and you never be able to get any odd. So you never be able to satisfy that inequality. So this one No good. Let's talk about the next one, even and odd. So let's say this is even and this is odd. Then when you add an even and an odd, the next one would be odd. All right, so that's the pattern here. Then you add two odds, these two, and you get an even. Then you add an odd and an even, and you get odd. And then you just keep going like that. You don't need me to talk you through it. So it's EOO, EOO, like that. Now, we're going all the way to the 2020th term. So this EOO, EOO, EOO will keep continuing, right? Now, what happens at the very end, though? Well, if this number was perfectly divisible by 3, it would just end as EOO. But it's not divisible by 3. 2019 is divisible by 3. So, that basically means that this ends like this, because this is the 2019th term. And the very last one will be E, because it's part of the EOO repeating sequence. Okay, now let's talk about odd and even. Odd and even for scenario number, I'll just call it scenario number 1. How many odd and how many even do we have for this scenario? Well, I'm just going to concentrate on the 2019, and then we'll add one extra E at the very end. There's 2019, and each of them are broken up into segments of 3, right? EOO, EOO. So first take 2019 divided by 3. And when you do, you get 673. So that means there's 673 of these EOOs. Well, that means there's 673 E's, because each of those EOOs has one E. 673 goes there. And then how many odds? Well, each EOO has 2 O's, so 673 times 2 would be the number of odds. And 673 times 2 is 1346. But don't forget the last E, so that's going to add here. So to make that 674. Okay, so now we have to go back and see if that inequality is satisfied. 1346, is it greater than 2 times 674? That would mean 1346 has to be greater than 674 times 2 is 1348. And that is not true. So that is no good. So scenario number 1, no good. We can't have a sequence that begins like that. All right, no problem. Let's keep going. We have another way of doing this. Another way of doing it would be, instead of putting E first, I can put O first. So that means instead of EO, it would be OE. So odd and then E. And then now let's just use our rules here. I mean, you don't really need to memorize them. I'm sure you know them by heart. Odd plus even. Odd plus even is odd. Even plus odd is odd. Odd plus odd is even. Okay? Odd plus even, that's odd. Even plus odd is odd. All right. It looks like another EOO situation. The only difference is this time it's shifted a little bit. We started with an O, and then it's EOO, EOO, and so on. All right, so let's make a little bit of space, since I don't really even need that, since I had already mentioned that we're not even going to care about that even plus even stuff. So let's get down to the very last 4 and see what happens. It looks like, since it's being shifted 1 to the right, it will just end up as EOO like that. All right, perfect. Now let's go back to our table and let's figure out what this called scenario 2. So let's figure out what our scenario 2 is. How many odd, how many even? It's the same story, actually. I think you can do this. There's 2019 numbers, if you don't count that one, because that's sort of like the odd one out, right? So the 2019 divided by 3, I had written that in, it's 673. So that basically means that there's 673 of these EOO sequences. Each of those gives one E. So there's 673 E's. Remember, odd and even. And then how many odd are there? Well, each of those 673 gives 2 odds. So 2 times 673 would be the number of odds. And then don't forget, there's one extra 1 at the very end. So when you do that math, 673 times 2 plus 1 would give you 1347. Okay, so now we have to see if this inequality holds true. Is x greater than 2 times 220 minus x? Okay, so that means 1347. Is it greater than 2 times 673? That means 1347 would have to be greater than 1346. And the answer is yes. Great. So I will accept that as a possible way of doing this. And then, of course, we have one more situation. We started off with this one, EO, which was this one right here, EO. We then did OE, which is this one right here, OE. And now we have to do the third one, which is odd, as the first two. So OO, like that. All right, let's make this list. OO, E. Then O plus E is O. E plus O is O. OO is E. Okay, so this just goes OOE, OOE, like that. All right, and then when I get all the way all the way down to the last 4, what do I have? Well, very similar to before. This is the final one, right? That's to the 2020th, and then this one is the 2019. Because 2019 is divisible by 3, the last 3 until 2019 will be OOE, because 2019 divides into 3 perfectly. And therefore that 2020th will be O. Okay, same story. How many O's and how many E's? So we got 3. Scenario 3. How many O's and how many E's? Well, again, 2019 divided by 3 is 673. For each one of those 673, we get one of these 3 segment sequences, and each one gives 1 E. So there will be 673 E's. So 673 E's, evens. And then for the odds of those 673 strings, each will produce 2 odds. So 673 times 2. And then don't forget that one odd man out at the very end. So 673 times 2 plus 1, and that is 1347. So 1347 goes here. So we have to now check this inequality right here to see if it's true. Is 1347 greater than 2 times 673? And the answer is yes. The answer is yes. I can cheat a little bit because I've already done that up here. It's pretty much the exact same mathematics. All right, so that concludes that part of the question. Now I know which ones to choose. I can either choose this scenario or this scenario. All right, so now we have to figure out what is M. Let's go back and figure out what M is. For every positive integer M, there are exactly 2, 4, 1, 5 sequences where the first 2 terms are each less than 2m. Okay, less than 2m. So let's just start with an answer choice. I think that is the best way. Will make it clear. If I start with m, it might get a little too abstract and I might lose you. So I'm going to just start with a number. Let's say m was equal to 21. So that means that each of those first 2 terms, A and B, which is what I called them, each is less than 2m. So A is less than 2m, which is 42, and B is less than 2m, which is 42. Okay, now let's talk about scenario 2 and then scenario 3. Scenario 2 and scenario 3. Scenario 2 and scenario 3. So scenario 2 basically says that there has to be an even as my first and then an odd as my second number, which is right here. Or either way, I mean, I just reversed it, but I think it's important that you not reverse it. So let's keep an order here, odd and then even. So it's very important that you do not reverse it, because this is valid, but this is not. All right? So be careful there. Now, I have to figure out how many A's are there and how many B's are there. Well, A is less than 42. A is an odd number. How many odd numbers are there less than 42? You tell me. Well, 41 is the largest one, and then you just keep going down, right? 39, and then 37, all the way down to 1. That, if you do the counting, or you can do it in your head, gives me 21 possible numbers. Now let's do the same thing for B. B is an even number, and B is less than 42. How many even numbers are there less than 42? Well, you're starting with 40, and then basically from 1 to 40, how many even numbers? Well, you can just divide by 2. That makes it easy, right? That gives you 20. So 20. So that's basically how you would do this. And then all these other numbers will originate from those first two. So we only need to worry about the first two. There's 21 possible choices for A and 20 possible choices for B. And that gives me 21 times 20, which is 420. Okay, now we'll do it for 3. This scenario right here. This scenario basically was this one right here. Odd and odd for the first two. So that means A is odd and B is odd. Okay, same numbers. You tell me, how many odd numbers are there less than 42? Well, I kind of gave you the answer about a minute ago. There's 21. And how many odd numbers are there for B less than 42? Well, it's the same, 21. So we got 21 times 21, which is 441 possible ways of placing this number and this number together. Okay, so now I add these two, and when I do, I get 861. Okay, that's great, but here's the thing. That number has to be 2415. And you say, okay, well, do I have to do this for every single one? No, not really. I just wanted to illustrate it with a number to make you understand, because if I used them, it would be a little too abstract. Okay, now that you're an expert, we can figure this out using M's. It seems to me, and look at the numbers will help tremendously, for any M, it looks to me that this is M and this is M minus 1. So this multiplication would essentially just be M times M minus 1. And then for this, it looks like this is M, this is M, and then therefore this multiplication is just M times M. So I conclude that M times M minus 1 plus M times M, which is M squared, that must be equal to my 2415. When I set M equal to 21, I fell short because that sum is only 861. But this equation should allow me to get the exact value of M. That gives me the sum that I require. Okay, you can either factor this or do a quadratic. Here we go. So this will be M squared minus M plus M squared is equal to 2415. 2M squared minus M minus 2415 is equal to 0. I don't feel like factoring because off the top of my head, I can't figure this out. So no problem, use a quadratic. M is equal to minus B plus or minus the square root of B squared minus 4AC. And on the Canadian exams, you're allowed to use a calculator. So this will be 1 plus or minus. When you do that and you take the square root, you get 139. Very nice integer. And then obviously, you're going to take the positive one. So 1 plus 139 divided by 4 is 35. And there you go. That is the answer to this very challenging question, because this comes from a grade 8 math contest. That is elementary school. Number 25, the answer is D. Square PQRS has side length of 8. It is split into 4 rectangular regions by 2 line segments, one parallel to PQ and one parallel to QR. There are n ways in which these line segments can be drawn so that the area of the 4 rectangular regions is a positive integer. What is the remainder when n squared is divided by 100? Well, let's talk about it. First, we have just our standard PQRS. And here we go, PQRS. And this is split up into segments of length 8, right? So each side is 8. So I'm just going to break it up into integers. So this is 1, 2, 3, 4, 5, 6, 7, and then this would be 8 right at the very end. And in a very similar way, we do the same thing on the side, and it would basically be identical. 1, 2, 3, 4, 5, 6, 7, 8, like that. Now, let's break it up into different categories. The first category is when the breaks are made such that they're made on an integer. So, for example, let's say I made the first one to happen entirely that it cuts through 2. And the second one, anywhere really, let's say it cuts through 5. So those are my two splits. And let's see what happens. So the first one, the area would be 2 times 5, which is 10. The next one, the area would be 6 times 5, which is 30. 2 times 3, which is 6. And 6 times 3, which is 18, right? So clearly, those are all positive integers, so that's great. And now we have to figure out how many ways are there to do this. The one that goes top to bottom, obviously, that's the vertical, so I'll just call that the V. And the one that goes left to right, that's obviously horizontal, so I'll just call that H. V for vertical, H for horizontal, right? Whatever you want to call them. For V, there's 7 possible choices. Either 1, 2, 3, 4, 5, 6, 7, right? Can't be 8 because then it wouldn't be cut into 4 different segments. If you made the line right on QR, it would basically end up cutting it into 2 segments. So we have 7 choices for V when we want just integers. And very similarly, there's 7 choices for H. So 7 times 7 is 49. So there you go. That's part of the answer. But we've got a few more scenarios, right? The next scenario is when you have the following. We made the first cuts with integers, but what if you made a cut so that it is halfway, like 0.5, so 1.5. I'm making that cut at 1.5. So that is going to give me another scenario. So I'll call this one integers, where both V and H were made where there's an integer. The next one I'm going to call 0.5. In particular, 0.5 for my horizontal cut for the H, right? So for example, 1.5 was what I drew on the diagram. Now what happens? How do I get integers? If H is a 0.5, 1.5, 2.5, like that, the only time you're going to get integer values if V is equal to either 2, 4, or 6. And I'll prove it to you with one example. Let's say V is 2, right? Okay, if V is 2, then what do we have for our areas? Let's write them in. The first one would be 2 times 1.5, which is 3. The next area would be 2 times 8 minus 1.5, which is 6.5. So 6.5 times 2 is 13. And the next one on this side here, that would be what, 6, right? So 6 times 1.5 is 9. And then on this side, it would be 6.5 times 6, which is 39. So great, it all works out. So as I hope I've proved, it works for the 0.5s only when V is either 2, 4, or 6. So that means if I were to figure out how many total, for V, it looks like I've got 3 choices, either 2, 4, or 6. And for H, how many 0.5s? Okay, that's going to Gotta think about this. I get 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5. So 1, 2, 3, 4, 5, 6, 7, 8. 8 of those. So 8 times 8 possible choices for the h. And you got to multiply them, so that's 24. Okay, so hopefully that makes sense. Now let's continue with that. The next one, continuing in the same way, is what happens now. I did 0.5, right? So what happens if I were to try to multiply by a 3? Well, how about if I had like a 0.33, which is really just 0.3 repeat. The 0.3s for the h. I would have to multiply by 3 in order to make that an integer, correct? But the problem is it will for the first one, but it falls apart for the next one. So let me just give you a quick example. Let's say I chose my h to be 1.33, right? And then therefore I chose my v to be the number 3. So the 1.33 cut is somewhere here, right? And then the 3 cut is right here. Let's see what happens. For the first area, I'll just draw it really quickly over here on the side. This is 3 and this is your 1.3 repeat. This becomes 4. So you think, okay, that's great. That works out. But unfortunately, it falls apart immediately on the next one. The next one would be 5 times 1.33, and that is unfortunately 6.66, which is not an integer. So for these 0.3s, it doesn't work. Okay, so now let's go back and look at what else we can do. The next one is if we have a situation where you're multiplying by 4 this time. We tried the 1, right? That was no problem. 2, we got some solutions. 3, we got nothing. How about 4? In order to get an integer, that would now mean a 0.25. Those guys for h. And after careful thought, you will see that this only works. It only works with one value for v. That's when v is 4. So I'll give an example. Let's say h is 1.25. Okay, so we'll do it. We can do it on this diagram, not a problem. So approximately here, right? 1.25, and we're using v equals 4. So right down the middle. Okay, let's see what numbers we get. So we've got 1.25 and we've got 4. So the first one, 4 times 1.25, well, obviously that's going to be 5. So that's great. So there's a 5 in here. And then this is going to be 5 also. And then what about the next one? The next one would be 8 minus 1.25, which is 6.75 times 4, which is 27. And this also is 27. So it all works out. So how many for v and h? Well, for v, there's only one number, that being the 4. For h, though, so I got to think about this. How many 0.25s? Well, from 0 to 1, there's 0.25, there's 0.5, and 0.75, right? 0.25, 0.5, and 0.75. But I don't want to include this guy because this guy has already been included up here. So I just want to include these guys. So there's really only 2 between each integer. So 2 there, and so on. So 2, 4, 6, 8, 10, 12, 14, 16. 16 of those that would fit for h. So 1 times 16 is just 16. Okay. And then we just keep going. But for the sake of time, I will just write these out. If you try the next one, right, which is 5, where we had done v equals 3 and then 4, 3 and 4. If you do 5, then we have to use 0.2s, correct, for the h, if v equals 5. And I will let you figure out why, but there's no solutions here. It does not work. Meaning you won't be able to get a scenario where all 4 are integers. And in a very similar way, if you keep going, if v equals 6, then you would get this 0.16 repeat, right? 1 over 6 basically for the h. And very similarly, again, it does not work. And then the last one, when v equals 6, you get a 1 over 7 scenario, the 1 over 7s, and for h. And very similarly, it doesn't work. It doesn't create a scenario where you have 4 separate areas that are all integers. So let's recap here. The only ones I got to work were these 49, these 24, and these 16. Correct? But here's the thing. These ones are perfectly fine the way they are. No problem. But these ones, we can double them because notice that scenario can also be flipped. We can also have h and v flipped. So you can have the 3 possible numbers for h and 8 possible numbers for v. And that would give you another 24. So you notice here I gave you v equals 2 and h equals 1.5. I could have also done the same thing as v equals 1.5 and h equals 2. So that's why you get another 24. And very similarly down here, you can do the exact same thing. You notice how I gave an example of v equals 4 and h equals 1.25. I can also flip it by giving, for example, v equals 1.25 and h equals 4. And that would give me an additional 16. So I've got 49, 24, 24, 16, 16. So let's add that up. 49 plus 24 plus 24 plus 16 plus 16. That is my n. That's the total number of solutions. And that number is 129. And what they wanted me to figure out was n squared, which would be 16641. And then divide this by 100 and see what the remainder is. Well, the remainder obviously is going to be a 41. And that's the answer. So number 25, 41 would be D.